Welcome to the Ardupilot Developers Conference 2025, organised by KH Unmanned, hosted by 3DXR in North Yorkshire. With thanks to our sponsors, 3DXR, Aero Systems West, CUAV, Q-Pilot, High-Tech, Holy Bro, IR-Lock, KH Unmanned, Kraus Hamdani Aerospace, Maytech, Modal AI, Northwest Blue, SD Model, and Theseus.
Good morning. Day 3, final day. Here we go. Did you all have a good time last night? Yeah. Super. Thank you. Okay, just a very little bit from myself this morning, just to cover off some admin. So the weather outlook at the moment looks good for the morning, and we've got some rain coming in around about 4 o'clock. We have shuffled around some of the demos to try and get them all in. So Stephen, thank you very much for accommodating that and allow us to put your rover demo at the end of the day. Please let us know if there's any issues with rain in your demo, because we might shuffle the talks around a little bit more just to make sure that you have a fair shot at that. Sunset today is just after 7:30. And there's no change of state, so there's no new NOTAMs to affect flight operations. Our NOTAM is still in place. Obviously stay vigilant as to any of the low-flying aircraft that might come through the area. We have another very busy day ahead with lots of talks, so we're going to have to be quite quick fire on some of the changes. And there have been a few last-minute changes in the timetable that we made last night. When you go onto the website, please make sure you hard reload the website so that you're not looking at potentially cached timetable, just so you can stay up to date with the latest. We're going to have to be incredibly strict on timings today. We've got quite a few people who are departing on buses, and I want to make sure that we stay in time to get those people departed. A couple of general points. Today, in the UK, there's going to be a test of the emergency alert text system. We're expecting that it's going to be at 3 p.m. It will basically everybody's phones, unless it's switched off or on airplane mode, irrelevant of whether they're on silent, they will make a very annoying noise and alert everybody. It should be around 3 o'clock, but it's not always absolutely bang on. Hopefully, it will be at 3 o'clock and just before on a changeover between some talks. Can't guarantee that. If it does happen, if we can, we'll just sort of extend that talk by 5 minutes to give everyone a chance to sort of get over that and settle down, and then we'll resume. It is a test. I should emphasize it's a test. There is not an actual emergency going to happen at that time. Some equipment has been left in Muse 3. Some of the bulkier equipment, please collect from us tonight. And there is a USB cable and a little soldering iron that was left. That is now on the registration desk. It's got green tape around it. If it's yours, please collect it. I think we found the owner. And a little favor from myself, Peter, and Ben. It's been amazing hosting this conference, and as a little memento for us, we have set out 2 of the banners over on the tables over there. And if you'd be so kind, I'd really appreciate it if you could go over and sign both banners. One will be for 3DXR to hang up in their workshop, and the other will be for Peter and I to hang up in ours. Any questions before we get going? Great. So, Leonard, you're up if you want to start setting up.
Hello. Yeah, cool. G'day everybody. So my name's Leonard Hall. I've got 35 minutes. I have a reputation for running overtime, so I'm going to try and get this done in 30 minutes and then get some questions at the end for people. So I'm going to skip through this pretty quick. Okay, so this talk's going to be on some cooperative lift algorithms I've been working on. And we'll maybe start to explain some of the work, some of these talks I've been giving in the past. Maybe some of the fireworks drone displays might be interested in some of this work too. Why is that not changing? Sorry, it's changing on my screen and not on yours. There we go. All right. So, first up, I'd like to give a little bit of an overview of what we've been doing and what we're trying to work towards. A lot of PRs that we've been working on over the last year or so have been working towards some of the things in this talk, but also trying to take a few steps that we've been talking about taking for a long time. And I discovered that a big part of why we haven't been taking those steps has been because I haven't got off my butt and actually made a few things happen. Because a lot of it's actually around the actual attitude controller, position controller library. So one of the things Randy and I recently added in was 3D offset support in the position control library. And that allows you to actually command a separate kinematic path relative to your current location, and that current location can be moving on auto mission. So it potentially gives us the capability for you to separately offset your aircraft from an auto mission if you're doing inspections and that sort of stuff, while running an auto mission to adjust positions along a track. And on the right there, this is also going to really help with EKF lane switching, because it allows us to put the EKF offset, the difference between the two EKF states, into the offsets and then elegantly kinematically shape the transition back. Whereas at the moment, if you're doing an auto mission, for example, which is an absolute position, the EKF will jump back and forth between the two every time it switches, and you'll get a large twitch. You've probably seen a lot of work coming through on the follow library. We've moved that to an absolute location from origin, and that has then enabled us to use real-time S-curves. And if you don't know what real-time S-curves are, that's a kinematic, like a kinematic filter. It's a kinematic limited filter to upsample data from the other aircraft and actually pass it through. That's then led to update mode follow to use the real-time S-curve interface in the position controller, which allows us to get much better follow quality, and I'll be demonstrating some of that soon. Auto-tune has been reverted back to, had all its old protections put back in, so you'll find it will actually kick out of auto-tune and tell you to find another way rather than doing its best and potentially giving you a poor tune. So hope that is there to try and improve safety of auto-tune and the reliability of auto-tune. So another thing, work with Peter Barker, parameter right protection. Coming in soon, a Lua script that allows you to whitelist parameters, so only allow you a subset of parameters you can change while it's enabled. Huge improvement in safety with those accidentally changed parameters. You know, allows you, the Lua script that Peter is going to put out allows you to switch between parameter sets and stuff as well, which I have found incredibly useful for changing payloads and that sort of things on aircraft with a single, just choose your payload and that configuration comes in and is checked. Then we're getting to the real good stuff. We've been working on updating the attitude controller interface. Internally, the attitude controller is already radians, but we took in centi-degrees, and we've actually changed that to completely use radians in Copter. And that sort of saved a lot of space and simplifies the maths a lot. And we've also done that with the position controller, moving from centimetres to metres. And with the final step there, we actually want to move to NED as well. And also completely removed INAV, which was a big step. And all this is working towards moving to SI units on the parameters. And basically, when we get back from this conference, Randy and I are going to work to do all of that conversion. The other thing that two other little things we've actually, some people saw the little coordinated turn loiter that we were demonstrating out in the thing. We're going to get that in, see how people feel about that. A lot of people's feedback the other day was great, and I want to add in circular waypoint segments for Copter. And all this is sort of targeted for 4.7. All right, so I'm going to have to really skip through here. All right, so this is about cooperative lift. Now, cooperative lift is sort of a form of swarming, but it's about close formation of aircraft, whereas swarming, it's about sort of mutual navigation of aircraft in a space. Cooperative lift is almost, it takes it one step forward where you're actually trying to mirror aircraft in space. You're trying to turn multiple aircraft into a single physical structure to impart a force on an object that they are all linked to in some way. So in this case, we've got a single load with where that load, that payload is actually, the weight of that payload is distributed amongst multiple aircraft to move that around the sky. Ideally, we want to optimize power consumption over emission, so one aircraft doesn't go flat while the other three are pottering along, only needing to carry their own weight. Ideally, with the intent of keeping, at the end of a mission, all the aircraft actually work to have the same flight duration remaining at the end of a mission, even if they start out with different energy storage levels at the beginning of a mission. And the other thing we need to consider as we're doing this, that's going to be a little bit interesting, is actually setting up these cooperative lift swarms to begin with, because the last thing you want is two aircraft deciding that they should be on the opposite side of a payload and coming together in mid-air. All right, so what we've got to start off with is we've got loiter. Now, loiter is not great because it's not well kinematically constrained. In particular, you've got very high jerk rates following your stick. Auto, which has perfect kinematic constraints, but we have no way of synchronizing auto missions rather than starting them at the same time. We've got mode follow, which is what I'll show in a second, which has a lot of potential, but the original mode follow, which is sort of the motivation to a lot of these changes, had very poor kinematic shaping and very, very poor coupling between the lead aircraft and the following aircraft. And then there's mode guided, which you see the light show drones using. And although that is fantastic, you then need a separate companion computer to control all those aircraft, or a Lua script passing dealing with it and passing that out. So, the first solution I'm going to show is based around mode follow. Now, mode follow, basically, it gives you an offset between two aircraft. It provides a vector offset between two aircraft, horizontal and vertical, and it allows you to actually set that offset relative to the heading of the lead vehicle or just fixed northeast down. So, in order to actually make this work the way we needed to, we needed, like the original mode follow was basically a P-term position, error, velocity command. And basically that meant that the aircraft's on a rubber band. So when you're moving, the error is large, and when you're stationary, the error becomes zero again. So you get this sort of stretching between the aircraft, which isn't great if the two aircraft are tied together. The other problem is it's based on global position int, which is just a position and a velocity, and it's derived from aircraft position, so it's inherently got a significant amount of noise in it. It's the aircraft's position and the aircraft's velocity. So we want to solve a number of those things. I'll go through how we've solved those. So instead of the new follow me actually enables position, velocity, and acceleration matching between aircraft, not just this position following thing. And we do that using real-time S-curves to interpolate that low data rate reference that's coming from the lead aircraft and turn it into a 400 hertz 400 hertz smooth kinematic path that the following aircraft can follow, so we don't get these twitches coming through. We also implemented a follow target. Now, follow target's a nice message because it's got position, velocity, acceleration, and the quaternion of the lead vehicle, so there's a lot more data there for us to follow. And one of the tricks I did was I didn't base that on the aircraft's position, velocity, and acceleration. I based that on the position controller of the lead aircraft's target position, velocity, and acceleration. And by doing that, I'm not passing the lead vehicle's position to the following vehicle, I'm passing the lead vehicle's kinematic path, instantaneous kinematic path to the following vehicle. So I take out the lead vehicle's error associated with the position control and the lead aircraft's error associated with its own estimation of its position. So there's a lot of noise sources get removed. So both aircraft add their own noise around an ideal kinematic path as opposed to summing up their various noise sources. And this allows a master and end slave type system. So this is an example of that. So this is two Callistos. This is a light little, I think it's only about a 10 or 20 kilo payload. So we've got two Callistos taking off here. Now at the moment, the front aircraft is taking off in loiter. The rear aircraft, in this case, the rear aircraft is actually the lead aircraft is taking off in loiter. The front aircraft is then switched to follow mode, and you'll see a little bit of a movement there as it does that. We then take off, increase in altitude, and switch to auto, which then takes off and runs it's sort of a mission that goes like this, around and comes back again. And so you can see that the aircraft, the path of the two aircraft, despite we've got this swinging load beneath the aircraft, is really nice. We're not getting, it's very nice mirroring of the aircraft. And so here we come back again, and we're coming back to the mission where we come back, and now we're doing a land, and again the lead aircraft is following the front aircraft is following the lead aircraft that's behind all the way down through the land. And what we do right at the end is the following aircraft, we switch it to loiter and hold it down on the ground and disarm it. So this is another view of this aircraft. Now this is another test. This is a 54 kilo payload between the two aircraft. So the same situation again. You can see there's a bit of a larger stack of weight. So you can see that the two aircraft, the synchronization between the two aircraft is very tight. Now, sorry about the cameraman here. There's a few places where he moves off. So again, taking off the weight, so you can sort of see the size of that bundle of weight there. We actually made a mistake when we did this. We didn't add it up right. We were aiming for, we thought it was 48 kilo, and it wasn't until we looked afterwards. It was actually 54 kilo. The maximum rated takeoff weight of the Callisto with these batteries is actually about 26 kilograms. So this cooperative lift actually exceeded our formal maximum takeoff weight, but what's a couple of kilo between friends? But, you know, given that these aircraft are, it's a 15-metre line and 10 metres offset, so there's a reasonable angle pulling the aircraft together, yeah, somebody's crutch, you know, the aircraft could sit there and handle it and navigate very precisely despite that, that lateral load on the aircraft, trying to pull them together at the top. And you can see even as the aircraft lost load, both of them respond in the same way to that, that load. And that's where the aircraft having the same target locations rather than basing each other's positions off the other aircraft's positions. That's one of those instances where we would see a disturbance between the two aircraft with an addition of the errors adding up between aircraft. Whereas because they're both following the same target and they're both adding they've both got a similar load change, they both have the same position controller response, and they both continue to be well synchronized. So this is another view that this is the again the 54 kilo payload, and this gives a nice indication of like you can actually see the following aircraft from the lead aircraft all the way around. And yeah, so you can sort of see it stays very much in the same frame. Like the following aircraft pretty much stays in exactly the same place in the frame, exactly the same scale factor all the way through. And you can see even with their 54 kilos, we actually set up this to deliberately get a big swing of that 54 kilos left and right. But also when it's with forwards and back, that 54 kilos isn't able to move forwards and back between the aircraft. So it's, there's a significant delta load between the aircraft in the forwards and back case. And the aircraft are all able to sort of handle that, and you can see as that 54 kilos is swinging out and the aircraft have to hold against it. They're both sharing that load and reacting in the same way as it deals with that. Okay, so that's the follow solution, and that's the only one I've been able to actually demonstrate, but it clearly demonstrated that we could tightly couple a couple of aircraft together. Now we come on, the other option that I'd like to explore is auto mode. Now, the key problem with auto is we've got these waypoints that we're running around. We use a raised Kyson S-curve kinematic path between them, and that has a very, very precise timing. And that timing, we only deviate from that timing when there is saturation in the system, when you've got a headwind, when you can't, you've got a crosswind and you can't maintain your forward speed without losing, creating cross-track error and things like that. And we have this time compression concept where when we start to see we can't keep up with the position along that S-curve trajectory, that raised cosine S-curve trajectory, we slow down time so that we can keep up to it. We do a couple other little things with acceleration, so even though we're only doing half the speed that we expect to do, the accelerations that we request are all consistent with that speed, and we get a nice elegant slowdown to the stop at the other end. So what we would like to do is solve that synchronization problem by passing that time, that time reference between aircraft. So basically, all of the aircraft in that coupled swarm slow down to the slowest aircraft. But how do you do that with multiple different auto missions, because they all have to be offset by whatever that swarm size is. And this is where the offset work comes in that Randy and I did. And so what we've got is we actually have an identical auto mission that all of the aircraft are following, and they all run different offsets from that same mission. So those missions are like nanosecond identical, like to the tolerance of your floating point number. So by running that and synchronizing the timestamps along that auto mission amongst all 4 aircraft, and then applying different offsets for each of the aircraft in that tightly coupled swarm, we're able to fly multiple aircraft, 4, 3, 2, around that auto mission and control that payload. The other, so the key advantage of that versus the follow me we have to pass that whole message, and we need to be getting to about 20 times a second, because your data rate needs to be proportional to how complex and how fast changing your flight state is. Because all of the aircraft already know all the things they're expected to do throughout this mission, they no longer need a high data rate to convey that information because they've already got that information. So you only need a data rate proportional to how quickly any given aircraft will start falling behind in time. So really your data rate only needs to happen at all when there's a saturation event and one of the aircraft starts slowing down, right? And then we need to synchronize that slowdown between aircraft. So the data rate required between aircraft is dramatically lower. The other advantage of this is that we're able to control that those offsets in interesting ways. So if we have a directly coupled lines to a payload, we're able to control those offsets based on the acceleration requirements and the power requirements of the swarm, so that the front aircraft during acceleration can drop down and the swarm can rear up at the as the payload lags behind the swarm. And so the aircraft would fly like a tricopter, where each propeller of the tricopter is actually a complete aircraft in its own right. And so also as you're turning, this swarm can turn to balance that load, and this is all completely predictable. This is just physics, what's required to change this attitude. So we know what our acceleration request is going to be, so we know what the aircraft need to do. On top of that, we can pass in a battery remaining from every aircraft amongst the swarm, and all the aircraft can say, well, I've got the average battery remaining of my swarm is X, and I've got a bit more than that. So I can have a simple P term that if I've got a bit more than that, I'm going to actually fly a little bit higher in the swarm and take a little bit more load than everybody else until my battery remaining comes back down to the average. And so by lifting your corner of the load up, the load moves a little bit more under you. You take a little bit more of the load, you use a little bit more power, and everything balances out. With the goal being, you might take off with slightly different battery remaining, but by the time you're halfway through the mission, all the aircraft have perfectly matched battery remaining, and that will also sort of naturally take into account things like drag on your payload, tending to load up the front aircraft more than the rear aircraft and things like that. So the other problem we have with this, with all of this, is manual control. Follow me is not a manual control mode. Auto is most certainly not a manual control mode. So how do we, if we get it somewhere, generally, it's all fine and dandy if you already know where it needs to go, but what if you don't want it there, you actually want it there? How do you move a swarm across there? The requirement of these swarms is extremely tight kinematic path generation. Loiter is not a solution to that problem because it has loiter is a drag model based on old hold. Very high jerk rates. It's very poorly constrained. So what we've done is we've created this mode called crane mode. And crane mode has a number of nice properties. It most resembles the land, the velocity, the land adjust phase in landing, the nudge capability during landing. That is a velocity controlled mode where we set that up so that the maximum velocity is equal to half your acceleration. So when you put in a full stick and let go of the stick, the aircraft will come to an elegant stop quite quickly, so you can let go of the stick and not have it drift off to the side and maybe still be moving when you touch down. So it's a basic velocity controlled mode with 3 different speed settings and acceleration velocity combinations. And then there's a couple of things we've done in the position controller, how we handle saturation to make it behave nicely under load, which there'd be a whole talk on those factors. So we've created this crane mode that creates very nice kinematic paths that are then suitable, that have the same bandwidth requirements for the follow aircraft. So that's the overall system that we're dealing with. There's a few practical considerations that need to be considered here. First up, the physical connection between aircraft. There's 2 basic options there. One of them is the fixed thing. We've got a lot of control over the payload. It's basically an inverted tripod. And the other one we're considering is a pulley system. Now that doesn't allow us to load balance and that sort of stuff. It's inherently done by the physics, but it means we can't battery capacity balance very easily. But a multi-pulley system, the advantage of that is we let the pulley system deal with load sharing as opposed to the aircraft, so it allows us to start at a simpler place. So, final thing is data links. At the moment we're just using RFD 900s, but we are also considering a small little Wi-Fi dongle that goes on the swarm, because we're only literally dealing with a small little the distances between the aircraft are very small. All right, so have we got any questions?
Yeah, I absolutely love the idea that we could sell not just one drone to each customer, but potentially 3. I think that's absolutely brilliant.
Our plan is to do 4 Callistos and 100 kilos.
I might owe you a beer for that. But what I was going to ask is, we're intending to do offshore wind turbine operations with an underslung load. And I was interested in the module which has, where you can put a remote here for sensor there, and then you can communicate that with telemetry and sort of compensate. Is that something that you could build into crane mode, so there's an option to have just one, but still have the remote to compensation of the swinging load?
Well, that's what Randy demonstrated at, in Japan, was that compensation factor, where you're again using a passive swarm element and an active swarm element, and you're using the active swarm element to control the position of the passive one. So yeah, Randy demonstrated that that's not only feasible, it's relatively easy to do, if you're Randy. Yeah, so again, this is where that was one of the initial motivations of putting these offsets in. So you can use that offset to, you run your same auto mission, but the load's blown off to the side, so you offset the aircraft so that the load is at the original target location, not the aircraft. So yeah, so that was one of the applications of that offset feature, to do exactly that.
Okay, thank you.
Yeah, I had the same question, so somebody else can ask.
Has anybody got a different question?
Thanks, Leonard. I just want to say again how much I appreciate the work that you did on the follow library. It's amazing, and I used it obviously in the plane follow stuff. Wanted to ask about the follow target. I think Lewis, that's what I experimented with, using the Lewis script for a follow target. Is there, are you actually building the follow target now into the C++ code so it can generate that?
I haven't. That's not something that I have an intention of releasing, because it's quite a. It only works in position control modes. Like if we did follow target on the aircraft, it would probably follow the entire, like the aircraft, in the same way the global position int does, because otherwise, as soon as somebody went to any other mode, bad things would happen. So the way I've done it here has some serious safety concerns to the way you run your operation if you don't carefully sort of structure how you're doing things.
So what, don't do that, or?
No, so the follow target, so if you've got a low noise aircraft, the follow target implemented in the same way as the existing things will do almost as well.
Okay.
Yeah.
Thanks.
So for plane, you'd want to implement the follow target in the same way. It's just that you've also got acceleration data there that would then reduce the latency between your lead aircraft and your follow target.
Yeah, and I had to update the script to add stuff to get the plane-related information, because there was a bunch of, this works for copter, and if it doesn't work for copter, just don't do anything. And I had to add the plane stuff in. But okay, so the Lewis script is the answer anyway.
That's right. Yeah.
Got it. Okay, thanks, mate.
Thanks for the talk, Leonard. In the case where you use the same automation to fly all of the agents of the swarm, was there a case where slight errors in the GPS receivers would make it so that you are activating one waypoint a few fractions of a second before the other agent, and then what happens then?
Well, this is, the only check on the waypoints is that, so the auto mode is set up such that your target position has to go around the corner, like has to reach the waypoint, not you in auto. So in that way, it's actually it's not dependent on your actual location. so your GPS accuracies, provided you are within the window. So until your GPS accuracies get past a certain magnitude, that won't be a problem. But if they are, that aircraft will be slowing down the swarm anyway, so such that magnitude error is zeroed out. The danger is that aircraft, that the magnitude of that GPS error is precisely the distance between two aircraft and in precisely that direction. And we have two aircraft occupying the same space. And aircraft don't fly so well when their propeller discs share the same air. So,
I guess it's a very consistent way of checking your receiver consistency.
Yeah, that's right. But there are potential enhancements for passing RTK corrections between aircraft or using a full RTK setup for all aircraft. We'll initially just go with a full RTK setup, but we could run a differential RTK between aircraft.
Right. Thank you. I have kind of a follow-up question from the previous one. I just didn't quite get when you explain how you optimize the number of aircraft to do the task versus the velocity and acceleration. How do you optimize? There's must be a kind of equilibrium you have to form when you're doing the task. In your previous slides, I didn't quite get that part.
So were you talking about controlling the swing of the payload?
Yeah.
Okay, so that test was set up deliberately to excite payload swing. But if you're running a slung payload with a copter, in order to minimize excitation of the that slung payload, you need to set your kinematic limits of your auto mission such that the payload responds faster underneath you than you change your aircraft attitude. So that's a combination of your acceleration and jerk limits. And so if you're leaning sideways and accelerating off sideways, and your jerk limit, which is basically how fast you roll over as you're doing that up to your maximum acceleration, if that time to your maximum acceleration is faster than your pendulum time, what happens is you can see, and the pendulum does this behind you. If it's slower, the pendulum's always getting underneath you before you need it to. And so it doesn't absorb, it doesn't get excited, the swing doesn't get excited. And the same thing happens with the braking maneuver. You're coming along and you'll brake and move and the pendulum will sit underneath you and then you'll come to a stop like this without getting the swing of your payload. So whether you want to excite a swing like we did or whether you want to avoid exciting a swing comes down to the length of your pendulum and your acceleration and jerk limits.
Yeah, so in that case, how do I know that, let's say, how many aircraft will be the best number to use to do such a thing?
So you look at your time constant of your pendulum and you make sure acceleration divided by jerk is slower than that.
Yeah, that makes sense. Thank you very much.
You were talking about lead aircraft and offsets. Is there an option to change where, say, the centre of the yaw would be between the vehicles? Can you change that from, is it the lead aircraft? Can it be dead centre or can it be anywhere in between those aircraft?
So, the lead aircraft can be anywhere in the swarm. The difference between the follow me based solution and the auto-based solution is in the auto-based solution, the initial intent is to make the offset such that all the aircraft are equally spaced around the mission set point, and the payload is actually on the mission point. With the Follow Me, the lead aircraft is the origin, and all the aircraft are relative to that. So you can have the origin at the front and then a diamond of aircraft behind and the payload in the middle. What I suspect my final solution and the most general best performance solution will actually be Follow Me with offsets. So the lead aircraft will be running with offsets that put the origin over the payload, and all of the aircraft will then be running an offset. So effectively be Follow Me with zero distance using offsets rather than the offsets in Follow Me, and that way I can take advantage of the dynamic nature of offsets to do power equalization, well, you know, battery remaining equalization and load control.
And could you choose a different pattern? Say if you were choosing 3 aircraft and you were, say, lifting something, an I-beam, for instance,
Yep.
Can you do 3 in a row
Yes.
as well as the...
So you could have 2 load connection points and, you know, 4 aircraft each lifting the end of the I-beam, for example, and you could orientate that in space by controlling those offsets.
About, say, 3 in a row, for instance. I want 3
Yes,
vehicles, 1, 2, 3.
Yes, you could put 3 along the centre and, yeah.
Hi, Leonard. Thank you very much. So you discussed some of the considerations surrounding smaller position deviation, how the different modes are going to handle that. But one of the natural questions becomes, large fail-safe events. So you lose an aircraft, maybe an aircraft lose GNSS, something like that. Yep. Now, to be fair, you did mention that your future considerations consider this, but can you elaborate on some of your initial thoughts as to which modes are going to be more elegant for that?
So, the Follow Me mode obviously has a single point of failure, the lead aircraft. Lead aircraft goes down, you'd have to do a lot of really complex stuff to swap lead aircraft. The auto mode, that's one of the key advantages of the auto mode, is there's inherently it's a fully redundant system, assuming that you've got enough more than enough aircraft to pick the load, and then obviously there goes your redundancy. But in that case, basically our plans are, if stuff goes wrong with the Follow Me, they all drop and they all laterally spread. It'll just be a pop, 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 right. So don't do this over people, but we don't fly drones over people, so that's okay. So then with the auto mission, there is a potential to have 4 aircraft doing the job of 3, and allowing, in that case, an aircraft that loses link with the others could drop and climb and create vertical separation and let the swarm go underneath, and that line would then drop and dangle below. So there is that opportunity for improved redundancy with the auto solution.
Thank you very much. I appreciate it.
There's one down at the front here. Keeping him fit. If the next one's right at the back corner over there.
Just have a question on the legislation side of things. I'll target Australia, obviously, as we're all there. Does CASA see this as a swarm? They are connected, they're tethered together. Is this one aircraft, one operator sort of thing?
Well, we did it as each aircraft had a single operator, so at any point, both aircraft could release and separate. But yes, there is that potential to start working with this as a swarm. But the complexity of that is really about setting up, how you actually automate the setup. Because that's the sort of thing where those tools can make the difference between this being a safe, easy to do versus quite a complex, like my anxiety. Like at my initial thing, I made sure I wasn't wrong with everything I set up. I set a difference in 10 meters in altitude when I first set it all up to make sure they didn't do this, right? That would have been a short test. So I was pretty confident, but I wanted to know, right? So then I put them back down, went, yes, I haven't made any mistakes. It would be great if the tools did all that for you, and so that when they took off, they just adjusted into their perfect position and that sort of stuff. So with the right tools, I'm sure we could do it like that, but, crawl, walk, run. Okay, well, I think that's everybody.
Wonderful. Thank you very much, Leonard. Fantastic. Okay, so next up we have a joint demo, or a couple of demos, from Rhys Mainwaring and Ryan Friedman. Please can everybody head out to the takeoff and landing pad. The demo will start at 10.
Well, I got...
will shortly be resuming APDC 2025.
Hello. All right, my name is Ryan Friedman. Today I'm demoing a. No mic? No mic? Okay. Hello. My name is Ryan Friedman. I'm demonstrating a path planner. This path planner is written by Aerospace. Dade company. It's called SmartPlay. Just sort of like an web API where they have a path planner that runs in the cloud, and you can define your vehicle constraints. So if you're about extended Kancir, so I'm using Kancir planner today, you can define your vehicle constraints, and then the planner actually uses weather data to generate energy optimized routes. So it'll take advantage of your numbers around this particular energy system. And so what I'm demonstrating is just the first time I've ever done a path planner generated by the vehicle, so we'll see what happens. So what I have configured out in the middle of the field, you can see there's an obstacle for the tree. What I've done is manually set up the field fence around the tree, and then set the start to the south of the tree, and north to the north to both of my trees. And then the planner, you can ask it for these different optimizations, and we're just going to apply it to the customized route because we won't find what it is. And we'll just see whether the Cooperative can execute the plan. And so I read something like this, and I'm going to talk later that I'm going to show you, but it's basically a plugin to MAVLink where you can configure the start and goal on map, request the plan, and then it shows up on MAVLink, and then you send it to the vehicle and execute it. So the planner does run on the cloud currently, but they do have the ability to run it on embedded without, basically, if you're running the cloud, it's very high compute, so it can run a lot of optimizations, and then if you run on board with them, you do it real quick. So we'll see how it goes. All right, good to go? Yeah, you want to go? Yeah. All right. So right now we just engaged auto mode, so it's going to go to the first waypoint, which is to the south of the tree. Okay. Right now we're operating with no GCS connection, so it might RTL. I'm using a Wi-Fi module, so we might not have quite enough range. Oh yeah, it's RTL. Okay, so why don't we disable GCS 06 right now? Yeah, well, it's much hotter, so we might just have to pull out a random data. I thought it had GCS 06. All right, so that's first attempt, not successful because we have an RF link that doesn't have enough range. Speak up. Speak up? Okay. Can you go to the relative tab? Okay. Yeah, it should be the PW. Leave it to the demo gods. We could follow it if we do it. Yeah. Or if I can connect.
Anyway, it should be okay. Good luck.
All right, we're gonna do another attempt. This time we've changed our fail-safe settings.
Good to go.
I guess we don't have enough fail-safes to be able to fly without the link. It's fine, or it's fine. Yeah. I don't have it. Yeah. Okay, so I guess we'll have to come back with better fail-safe settings next time and show you the planner. Thank you.
You know what? We operated safely.
We did. We were safe. Yeah.
Right? Yeah, I think we might have to do a reboot because we set up without having.
Start automatically. Right. Okay. Well, I've got a USB cable. I can do that.
Yep. Should we move it to?
Do we only need to restart like the caller or the pod? Just the receiver. I'll grab my laptop. Is it that you're yeah, Wi-Fi. If you connect to the Wi-Fi, if you connect to the local Wi-Fi, there's a repeat button on there. You can actually connect to the receiver. Yeah.
That would be better.
Try on Wi-Fi first, and if it doesn't work, then pass it. Yeah, you need to connect to the dealer response button and then just reboot on that. Yeah, I can do it here.
I might have it on my computer actually. So
Yeah, I'm about to do it. Yeah, I'll see if I can do it. To reboot. Yeah, I'll see if I can do it online. There's on the basement thing. So
Yeah, I mean, if we can do it this way, we'll just
oh, we weren't getting it on the stream. We were just showing it. No time to get it on the stream. 3.4.3, right?
Yeah, we set that one.
I don't need it.
I told you.
Should have tried it now. It doesn't tend to do that. See if it connects.
It's you should be able to see the uptime 0.
No, it's automatically disconnected from Wi-Fi.
Oh. Okay, so the planner was. Oh, the planner probably gets too close to the fence.
We can easily fix that. What's your? We might have another go if you like.
Yeah, so the fence around the tree, it's so close to the fence. The planner goes right around the fence. Okay. Yeah.
Do I have another go? Can we increase the margin or decrease the fence margin? Or quit where we're at? Haven't got time. Okay.
I don't. Yeah, it's needs to be.
A Wi-Fi dongle.
Somebody want to put?
You guys want Wi-Fi dongle?
No, I heard you guys are saying that you're having issues RF Wi-Fi and Wi-Fi.
It was a fence. So the planner optimized the fence, and there's no margin. So
okay, sorry.
Just hit the fence. Yeah, that's all good. Hi. Normally I'm using plane, but plane is why.
Doesn't give a shit, yeah.
I never want to. Sort of like.
Well, it could be set up remote fence if you enable fence. That seems plausible. So it seems to come back at the same time.
Do you not have the batteries with their circular connectors? Seem to be a little loose at times. Yeah, that would be good. Were you able to get the serial data?
That's up and running, Rhys. I've removed motive manager brutally, by the way. Yeah.
Just the index people. Yeah, that's. Yep.
RC now? Right. It's always annoying that the LRLS thing.
Yep.
Last minute coding trick. You got your transmitter on.
Just complete flight checks. Yeah, I try and pick this up.
Right, all right. It's hard when under pressure with the crowd.
One piece hole missing and all that sort of stuff. So
Yeah.
So, the ready points that you put
yes,
in
do you want
yesterday.
to come and see the plan?
Yeah.
And like you can check.
But is it still in fixed wing RTL or the RTL?
Remove before flight.
So, East Mainwaring, right at Friedman, we're going to go through a plane path planning demo now. You ready to go, Rhys? Yes. Over to you. So, you. Adjust the mic. Okay, thank you for coming. The demo we're hoping to plan today is it's a one where we have a around the tree here. So the first part of the mission is three-way as well. We're going to take off and put the plane into a little circle over in the corner there, and we should fly back this way through a slot here in the fences to loiter over this way. And at that point, we are going to take the plane now this year. The rallying point. And if it's successfully able to upload pathway, in that mission, upload it and jump to the start of the return, and then take up to the site, and what we should do is come to the return, and then back to the
Auto now. Got telemetry via ELRS, but nothing on the ground station. So you guys have more of an idea what it's doing than we do.
It's doing the waypoints right now. It's halfway through. So now it's going to squeeze through the border, the virtual border that we set up. It's hit 10 waypoints so far.
So Ryan's got That's telemetry. You had a go.
It's disarmed. I'm disarmed.
Okay. Thanks, Ryan.
Yeah, wonderful.
Well, we've got to fly.
No, thank you very much, Rich. I wouldn't have thought that it was like
It's the road zero mapping. Yeah. And I saw there was data coming out the other point.
We will shortly be resuming APDC 2025. We will shortly be resuming APDC 2025.
Can I ask everybody to please take your seats? Please take your seats to get the next talk started.
Leave my phone there for a timer.
Okay. Ladies and gentlemen, final call. Please take your seats. Okay, thank you very much. Well, you all seen the show last night. So now Ben Pickard and Tamás Nepusz are going to go through the challenges of a drone light show. Over to you guys.
Cheers, guys. Good morning, everybody. Thank you for attending this talk. And today we're going to talk about the challenges of a drone light show. So I'm from a company here in the UK called Light Dynamics, and I'm joined on stage by Tamás, who leads on the technical software development side of our partner called Skybrush, based in Hungary. Hopefully you enjoyed the show last night. This talk couldn't be... Thank you. This presentation couldn't be any more aptly named other than the challenges we faced last night. So glad we got airborne, but a few challenges nonetheless. So a little bit about Light Dynamics firstly. So we're a UK-based manufacturer. All of our hardware and equipment is manufactured in the UK. Yes, there are items that we injection mold, etc., out in China, but most importantly, all of the PCB development, the pick and place, all of that assembly is done here in the UK. We've got a growing company, about 6 employees now. We're manufacturing these in-house. We've got 2 sort of core products on offer, which I'll get into shortly, essentially being the Pixel Light Show drone, which is our flagship drone, and the larger brother, soon to be released, the Pixel Pyro. We are authorized by the CEA here in the UK, as well as the FAA in the US. We've got a licensed manufacturing partnership out there, so we're producing actively in the UK and the US. And as I say, the Light show industry is certainly growing well. We're certainly nowhere near its peak yet. What's great about that is that as an Ardupilot community, we're testing on mass scale every time we fly. You know, we're not flying single drones. We're typically flying tens, hundreds, and in some cases thousands. And so that provides an awful lot of data to work off, rightly or wrongly. We've got approximately about 50% UK market share in terms of active light show operators here. We never envisaged the UK to be a market, if I'm honest, hence why we focus so heavily on the US. And so we're very pleased that we can actually make some traction on the doorstep. Just for reference, we're based in Nottinghamshire. It's about 2.5 hours south from where we are presently. So at the core of our development, in order, you know, right when me and Mark started the business, in order for us to remain competitive and offer a product that we could produce on scale reliably, the key part was to develop a motherboard. And so there are a number of key components that go into making a light show system work, primarily being the flight control system. So we've now got our own STM32H743 based directly on the board, integrating an F9P GNSS, and a ESP Wi-Fi module. We're just transitioning into using ESP32s. Essentially, the drones are running in a private Wi-Fi network. And so each drone is essentially an IP address, and we correlate that to match the system ID in Ardupilot. When it comes to stitching anything more than 250 drones together currently, we end up running parallel networks in different subnets, et cetera, et cetera. Sorry, I'm losing my mic here. Tamás does some rather clever stuff in SkyBrush that allows you to add some ID offsets in. We're hoping that one day we'll get round to some 32-bit SYS ID. We also have an SIK radio on board for secondary communications. We've got LED and pyrotechnic outputs from servo channels. And so what's quite unique from a manufacturer is that we've now been able to the motherboard so that the hardware internally is the same from the Pixel and the Pixel Pyro. Which streamlines our manufacturing process massively. One of the really, really unique features of our systems when we first developed it was the whole remote on-off feature. We're no longer talking about laying a single drone out in the field, plugging a battery in, and flying. We're talking about tens, hundreds, and thousands. And so, as we all know, traditionally the standard for turning a drone on and off is the battery connection. If you get a little bit excited and set up a show 4 hours prior to takeoff and you don't want the drone to sit there burning power, previous walks of life, people would have to go around and physically remove all. What we have collectively developed is our rather unique remote on-off feature. So essentially when the drone is inserted into the drone is then sat in a sleep mode. And essentially that's using 1% of battery per hour. The drone is then registering on its network, appearing in SkyBrush, and then you imagine you've got 500, 1,000 drones all laid out in this standby mode. We can click a single button in the GCS and all of the drones turn on. So nobody has to move a foot essentially at that point. Secondly, that correlates to quite a unique flight termination system, which is completely independent to the flight control, as demonstrated last night. Essentially, we have using a GPIO on the Wi-Fi module, we're able to essentially pull power from the main board. So the reason why that's quite unique, and it's becoming a requirement in the EASA for an independent flight termination system that's different to just a disarm command via the flight controller, is that if the EKF is in completely a confused state and it is not responding to commands, yes, clearly it still requires a Wi-Fi connection to be functional. But essentially we can just pull power. So we did have a couple of drones go a little bit AWOL last night, and fortunately procedures all worked and technology all worked as expected, and so we were able to terminate those drones in our sterile ground area and then literally pick up the pieces afterwards. But ask any operator, we'd sooner take that all day long than risk the potential of a drone going outside of our sterile area. So safety is at the utmost importance here. So this inner workings here is really what helped the business and the product feasible. As I mentioned, this is manufactured in the UK, so we actually manufacture these boards in Lincoln from an ISO 9001 certified facility, really to increase the reliability and optimize assembly times. but it's fantastic to be able to support this product from home soil. Yes, we're manufacturing in the US as a license, under license, but everything is homegrown here from the UK in Lincolnshire and Nottinghamshire. In terms of the product themselves, so we have Pixel, which is the smaller of the two. This is a 400-gram all-up-weight system. I'll leave these on the desk on the side so people can take a look afterwards if they want to. Both of these systems are operating from RTK. With the F9P GNSS, we're able to get down to centimetre level of accuracy, which we, given the size of the drones, we're actually taking the drones off at a half a metre spacing. So the drones are laid out on the ground at every 50 centimetres, and they then take off in trays to maintain that separation in the air of typically around 2 metres. We can get down all the way down to 1 to 1.5 metres in transitions in flight, but essentially that means with 1,100 drones, which you'll see a little bit later on in this presentation, we can lay out 1,100 drones in a 28-metre wide by 10-metre long ground area. So incredibly compact. Half a metre is just enough space to allow you to walk through the columns as well without tripping around too much. We've got dual C2, so Wi-Fi is the primary and the SIK secondary. We've got quite a unique 2S lithium-ion smart battery, which we developed again in-house with a compatible multi-port charger. So again, operating tens, hundreds, thousands of drones is so far detached from operating a single drone where you can get away with just plugging it into your smart charger, inputting a few values, and off you go. We really need to look at the whole process in terms of how we're handling, storing, managing, maintaining, and obviously assembling the drones itself. So it's a much, much bigger picture. And just out of interest, we can get a maximum show time of 15 minutes from the smaller drone. We then also have the Pyro, which is soon to be released. We've now received CAA certification here in the UK. And so we can essentially launch 4 pyrotechnics off the drone independently. They can be triggered simultaneously or independent points throughout the show. Again, that's a nice feature that's been integrated through into Skybrush. It's got a 400-gram payload capacity, and again can operate for a maximum show time of 15 minutes at its maximum takeoff mass. The other way to look at that is it's still got an LED on the bottom of the drone, so in the sky it's still functional as a light show drone, and some operators can use this as a standalone light show drone with no pyro attached and then get extended flight times up to 25 minutes. So going back to the battery charging, this is our rugged battery charging case. It can charge 20 of our smart batteries in about 1.5 hours. It's got an onboard, the batteries itself have got a BMS which manage that balancing of the cells independently. They're a 5,000 milliamp hour battery. And essentially the Pyro drone, again, looking at the bigger picture, the Pyro drone and the Pixel drone both use exactly the same battery. The only difference is that in the Pyro drone, we run 2 of the batteries in series. So, you've got complete control of your fleet management. You've not got independent battery chargers and batteries per different aircraft. So just taking a step back, we're always trying to look at this bigger picture and how the customer is going to be interacting with the equipment, because it can be a nightmare. So in terms of operating and the challenges attached to it, clearly you've got an extrapolated risk factor. You're no longer operating in a single drone. There are 1,000 times the chances of things going wrong, given that, multiplied by X, depending on how many drones you're operating. You've really got to be considering the transport, the handling, the storage, assembly, and maintenance of these drones. And the challenge becomes when you're operating anything above 200, 250, depending on how you're configuring your networks, you then need to start stitching, we call it, multiple networks together in what we call a parallel network. And so, crew fatigue, technical challenges. Last night we had our router completely lock up prior to flight, which is why we ended up getting some gaps in the show. We couldn't get another 20 drones attached to a new router in time quick enough, so we just had to, pray and hope for the best really at the end of the day. And typically in this kind of scenario, you're operating to a deadline, to a timeline. London, New Year's Eve, you couldn't expect anything really to go wrong, surely. And so what we're trying to factor in now is multiple states of redundancy and how we can pull out these teething issues. And yes, we're looking at onboard stuff we can do on the drone, which we'll come into shortly. some of you guys in the room have been working with us directly to develop, enhanced fail-safe features. But, there's still way, way more we can go at here, and we're just hoping that we can help. We have hopefully assisted helping identify some EKF and dual RTCM passing optimizations in the past, and we're really excited to keep that going, essentially. But actually, when it goes well, this is an example of 800 drones we were flying back in California in April, I believe. And actually, this is a Lord of the Rings theme show. And when it's executed well, we had 100% takeoff rate in this particular show, and it looks stunning. So this, just to give you a sheer idea of scale here, that formation you're seeing on the screen right now is 350 meters wide. So we're covering a large area. That's the dragon from Lord of the Rings. We had so this is about a 12-minute show. We had a smart return to home feature. So one of the really key things, one of the key questions we get asked is that, do you need to place a drone on the ground on a particular spot? The answer is no, you don't, thanks to these guys. And so the software, as long as the drone has got RTK positioning and you've laid out your grid correctly, the ground spacing, the software is then able to work out what drone is placed on which pad and calculate the trajectories that it needs to upload to that individual drone as part of the show upload process. And the smart return to home feature is essentially allowing the drones to return to the exact spot it took off from. In many shows, the drones do not land at the spot they took off from, and that's kind of irrelevant, really. But it can be quite nice for fleet management, particularly if you've got multiple subnets stitched together, then they can all go back away in their individual carriers. So what's next before I hand over to Tamás, in terms of where we would like to see this go, and I'm conscious I didn't want to bombard you with requests here, but certainly support for more SYSD capabilities. Are regularly operating beyond 250 drones, and that would certainly simplify our manufacturing lives a lot easier. And actually, key things as we demonstrated last night, sensor-specific fail-safes and automated detection. Fortunately, we've been operating for some time now. We're able to identify these potential rogue drones long before the event happens. We just need to try and take action at the right time so it then doesn't interfere with something else within the swarm. So yes, we can identify a drone that's perhaps looking a little bit unhappy, and we just need to make sure we can interact with it at the right point in the show. I'll just open up the floor for some quick Q&A while Tamás gets his presentation running, if that's okay. Any questions?
Who's first?
Just wondering, what are the most common reasons that, like, if you see one drone in the show or two drones in the show wigging out, what are the most common reasons for that? What are the most common failures that you see?
Yeah, so most common failure is down to the compass drifting. Essentially, we get toilet bowling. 90% of the time, a compass toilet bowl will recover itself and come back. We're very, very keen to explore how we can potentially remove the compass altogether. It is by far our most unreliable component within the platform.
I figured. I can help you with that.
Okay, fantastic.
Yeah.
You probably saw on my talk a lot of the discussions about the follow me, the S-curve kinematic path planning. What level are you going to with your path? Like, I assume you're using guided mode commands to convey your path?
Yeah, I think I can respond to the question. So basically what we are doing, I will talk about it a little bit later. We have our own drone show flight mode, which is using the guided mode behind the scenes, and we are updating position and velocity set points about 10 times per second. So we are not using the S-curve thing directly. The representation of the path that the drones are flying is a sequence of Bezier curves. So it's already smooth, and it already ensures that the points where the segments connect to each other, they have their velocity vectors aligned. So for our purposes, just using the guided mode directly and constantly updating the set points is enough.
So if you're using guided mode, you are using the real-time S-curves. What command are you using? Position, velocity, acceleration commands?
We are using position and velocity commands. In the firmware, there's an option to use either just plain positioning or position and velocity, or position, velocity, and acceleration. We don't use the acceleration part because the designers are usually working in external software where they're working with straight lines, and we can only go up to Bezier curves, so you don't really get useful acceleration information. And if you are using plain position control only, then what we see is that the drones are essentially lagging behind all the time compared to where they should be. And it feels like, it's like slow and damped down compared to what the designers originally had in mind. And position and velocity seems to be a nice compromise between the two.
Exactly, and that was the heart of the question I was asking. So when you're running a position only command, that grows with velocity. If you have position and velocity, you'll get a velocity error that grows as you change the velocity thing. So I was wondering at what level you needed to go to achieve the dynamic change in shapes that you're following and the curves that you're following. So thank you.
Great presentation. I was curious for swarm recovery, if you need to replace a drone during the maneuvers, what does that look like? Do you support that now? And if not, how do you think you could solve that?
So in terms of replacing a drone, if we identify a problem on the ground, then we can essentially pull that drone out of the show, swap another one into its place, and then just recalculate the show's mapping very, very quickly and re-upload the show directly to that new drone, essentially. So it is a very quick process.
As the if a drone has a failure in flight, how quickly, if they're at normal operating altitude, is from the time you recognize the failure till the time the next one launches?
Essentially, it depends what the failure is and how we're able to react. If we can, we'll try and go for a designated land command. The challenge is, if it's GPS, for instance, it could be landing on a trajectory and looking like it's drifting outside of our sterile ground area. The quickest way to interact is essentially do that flight termination command and just pull the power to the drone and physically pick up the pieces. Again, the cost of a drone versus the cost of not being able to operate and the risk of not being able to operate is greatly outweighed. But where we can, we'll always go for a landing. The guys have recently implemented a bubble geofence, so essentially all the way around the trajectory of the individual's drone's flight path, we can define in the parameters from Ardupilot at what point we want, if the drone's drifted beyond its trajectory, we can tell it to go into an automated landing. The challenge with that is that you have no control, because there's no intra-swarm communication, you've got no control on what could that then interact with on the way back down.
Got it, thank you.
If I could just interrupt, if we can pause the questions for the time being, let's let Tamás do the rest of his talk for now, and then we'll resume taking questions at the end of this time. Thank you.
Hello, everyone. Thank you for coming to this talk and listening to the deeper challenges that we have in implementing a drone light show. What I'm going to talk about is the software side of things. I initially wanted to make this talk really, really deeply technical, but when I was writing my slides, I realized that there are just so many things to explain and introduce that I think I'm just going to scratch the surface, and then if you have questions, then sure, just catch me in the corridors later on, and then I will be happy to explain everything. So a little bit about myself. I'm a computer scientist, got my PhD in artificial intelligence, and then I became the lead developer of Skybrush, the drone show software. I'm also the CIO at Colmot Robotics, which is a Hungarian startup that acts both as the manufacturer of Skybrush itself, but we are also working in other projects with swarm-related applications of drones. So what we really do well is not when we have one drone, but when we have tens or hundreds of them. And I think it's the best way to introduce Skybrush to you guys is to start with a demo. So what I'm going to show you is running a 100 drone show in simulation at roughly the same location where we were taking off from yesterday. That show was with 200 drones. My computer is unfortunately not able to simulate 200 drones in real time. So I'm just going to start up. Oh, sorry. Yep, now it works. Okay. So what you see here, there's two halves of the screen. The top half is a Skybrush server. This is the part that is communicating with the drones behind the scenes. What you see at the bottom is 100 instances of Ardupilot Fiddle running on my machine in parallel, simulating 100 drones. I tried it with 200, it didn't work. With 150, it was sort of okay-ish, but I thought it's better not to risk it for the presentation, and I'm going to start Skybrush Live now. Yeah, hang on. Okay, now it's working. Yeah, so this is the user interface of the actual software that we are using on the site when we are running a drone show. You can see 100 drones laid out on the field where we were took off from yesterday, and what we, when everything goes well on site, the only thing that you need to do is to click there in the show control panel, open the show file. System parses the show file. Okay, it needs some permission to access the folder. Yep. And then if all your drones are laid out in the field according to how the show is planned, then you just click on this magic wand icon, and then the system fits the takeoff grid of the show to your actual layout, and a view like this on the map. The yellow area is the area where the drones are going to fly during the show. This is not the show that we flew yesterday, so we didn't actually fly over the river. We were just flying above the takeoff area. Then you need to ask the software to figure out which drone is going to fly which trajectory. This is again just one click of a button. Then you approve the layout. This is like a checklist that you need to go through in order to start the show. You set up the geofence, which is created automatically around the convex hull of the show area with some padding around it. Then you do the upload. This is usually not this fast in the field, but if you have a good Wi-Fi network, then it is supposed to be. I mean, with a 2,000 drone test, we managed to reach about 800 drones per minute as an upload rate. So that's quite good. We had to use more threads, and it was a very beefy wireless network, but usually the upload process shouldn't take more than 2 to 3 minutes. Once it is done, you check that none of your drones are showing errors. There's a manual pre-flight check that you need to go through and tick each of these fields. I actually turned this check off for demo purposes because I don't want to do that. And you set a start time for the show, 15 seconds from now, set start time, and then you authorize the start of the show. And all the drones are receiving the authorization bit from the ground station, and then in 1 second, they should start their motors in phases and then start flying the show. So this is how it looks like when everything goes well on the field. The only thing that I haven't mentioned is that we need to use RTK corrections for the accuracy that we need for the drone show. So there's an RTK base station next to us, and then we also transmit the RTK corrections to the drones. I'm going to close this now and move on with the rest of the presentation, if I find that window. Okay, where were I? Okay. So yeah, most of you are engineers, so I guess this all means nothing to you if I'm not showing you how we do this. So the nice thing about Skybrush is that its core is entirely open source. So we have an open source Ardupilot fork that adds the drone show flight mode and adds several safety features on top of Ardupilot that make it possible to do this with this flight controller. The front end that you have seen, it's also completely open source. It's written in TypeScript and React, and you can download it. You can build it for yourself. You can tweak the user interface, which operators actually like very much, because sometimes they just feel that they need to hide some of the complexity, some of the configuration opportunities that our software gives to them, and then they are free to just go in and hide whatever they want, things that they don't want their pilots to mess around with. And the server itself, the part that is communicating with the drones, that's open core in the sense that with the open source part, you can safely run drone shows up to roughly 750, 1,000 drones. And at that point, you start reaching certain performance limits, which can be overcome by replacing certain parts of the server with more performant components written in Rust, and that part is not open source. So if you just want to run shows up to 1,000 drones, you're probably okay with the open source part. Beyond that, you will need a license and get the more performant components. But of course, even if you are running shows with just 100, it is well in your best interests to share some of your revenue with us in order to keep the whole project going. And let's talk a little bit about the show design process. So when we are designing a show, we have a plugin for Blender, which is like a generic 3D artist software. And our plugin allows you to design the trajectories and the light program for the drones, and also design the transitions between the formations. So you as a designer only have to be concerned about the formations themselves, and the transitions between them are figured out completely by the Blender plugin. It also provides real-time safety validations. So the blue dots at the top that you see on the screen, those are altitude warnings. Those drones are too high compared to the altitude limit that is configured in the software. We have real-time warnings for proximity issues, like two drones being too close to each other. And we also have velocity and acceleration constraints that are being validated in real time while you are working with the software. And when you are done with designing the show, you need to export it into a single show file, where the extension is SkyC, but it's actually a zip file. A zip file containing a bunch of JSON files. There's like one JSON file for each drone with the trajectory of the drone, one JSON file with the light program, and there are some auxiliary metadata files in there. It can be produced by hand from any other software if you want to, but we provide the plugin for Blender, and this is what works the best. And once you have the show file, of course, and we also support Pyro drones since 2017. So this is a New Year's Eve show from 2017, back in the old days when RTK was not common. So you could see that the safety distance between drones is much larger than what you are used to nowadays. And I think we also managed to set half of the airfield on fire at this time. So I'm not going to mention where this was. But Pyro is a dangerous thing, so it shouldn't be taken lightly. So when it comes to the show execution part, this is the most interesting part for me, because lots of logistic problems arise on the field. So in IKEA style, for a drone light show, you need, of course, you need the drones. You need lots of batteries. I mean, in practice, you need at least twice as many batteries as the number of drones, because sometimes you are just doing practice flights, and sometimes you just forget to charge them. So it's good to have at least twice as many as the number of drones. You need 2 ground stations, one primary and one secondary. Secondary is for the case when you trip over the primary one or anything breaks there. You need one RTK base station, which needs to be surveyed in before the show, and then it sends the RTK corrections to the drones. You need access points. For 200 drone show, you're probably okay with 2 access points, but as you have more and more drones, you need more and more wireless access points on the ground to cope with all the traffic from the drones. You need backup radio. This is a standard Holybro SIK radio. Any sort of radio would do that allows you to broadcast commands and RTK corrections to all the drones. They don't need to talk back over the secondary channel. That is left for the Wi-Fi. And what you don't need is a remote controller, which is crazy scary for me, but no one uses remote controllers in this industry nowadays. Back in the early days, we had remote controllers. We could switch flight modes from the remote controller. Somehow it just fell out of fashion, so this is how it works now. Okay, I'm going to skip a preparation part because you have seen it, how I've done it, and Ben was also talking a little bit about it. The point is that the most annoying part of the show is when you have set things up, you uploaded the show, and then you still have 2 hours to the start of the show because all the things start rushing on your head. Oh my God, what I've forgotten to do, what could go wrong, and things like that. This is the worst part of doing a show. Once you are past the takeoff phase, then it's pretty great. On board, we have a compact binary format storing the trajectories less than 10 kilobytes for a typical drone show. The trajectory is represented as a sequence of Bezier curves that are evaluated in real time to provide position and velocity set points. The light program is a bytecode with commands like set color now or start a fade to this color in this number of seconds. And we are simply using guided mode behind the scenes. And the set points are updated at 10 hertz. RTK corrections are injected on both channels redundantly, and then we deduplicate the packets before we forward them to the GPS. And we also have a compact telemetry stream similar to the high latency MAVLink packet, extended a little bit to contain more status bits that we need for the ground station. This is the important bit. This is what I really want to talk about. So the safety enhancements that you need for drone show. First, we have real-time drift warnings. So each drone checks how far it is from its set point and then shows you a warning on the screen when a drone is somehow drifting off the trajectory, which could be a result of bad show design, like when the designer is asking the drone to go 5 meters per second in one direction and then stop immediately. Of course, it will drift and then compensate back. That's normal. But when you have misbehaving drones, then it's very easy to identify them from the ground station. We have something called the hard geofence, which is a secondary geofence around the primary geofence. And if the drone hits the secondary hard geofence, it turns off the motors and falls down. This is something that is mandatory. So it is required by the CAA in most countries. And we also have the bubble fence that Ben mentioned, which I think is a better idea than the hard fence, but it's not mandatory at the moment. The bubble fence basically disarms the drone or sends it to land mode when it is too far from the planned trajectory. So you set up a bubble fence with a radius of 2 meters and a timeout of 3 seconds. And if the drone has drifted from its trajectory by more than 2 meters for more than 3 seconds, then it will either land or just disarm itself. Some people also use disarm on EKF failsafe, which is, a pretty drastic thing to do. But for shows with thousands of drones and when there's more money on the line, the audience is closed, then this is the safest thing to do. And finally, my Christmas wish list for the MAVLink developers out there. These are the things that we would love to have in MAVLink in order to make things easier for us. First is, well, Ben went with a 4-byte MAVLink system ID. I would be happy with 2. So if we could have 2-byte MAVLink system IDs, then we wouldn't need to partition our drone swarm into separate MAVLink networks to get over the 1-byte system ID limit in MAVLink. So it would be great. It would be great if we had error messages from the drone when we are trying to set a parameter that doesn't exist. Because right now, when you do that, you just don't get any response from the drone at all. And it's hard to tell whether you're not getting a response because the parameter doesn't exist or because the wireless network sucks and the packet got lost somewhere. So that's not that great. And the last thing that I would really like to have is broadcast file transfers, which could be used for firmware updates on thousands of drones. You upload an ABIN file to all the drones at the same time, and then you just reboot them, and bam, you have a firmware update on 1,000 drones. Or you could upload the entire show, all the trajectories of all the drones to every single drone, and then you can leave it for later to decide which drone is going to fly which trajectory, because they all have the entire show. Right now, each drone receives only one trajectory when we do the upload, because it would be just too much data to push through with unicast file transfers. If we had a broadcast file transfer, this would be great to have. Okay, so thank you for your attention, and now it's the time for the questions. There's a 300 drone show running on the screen, so the more questions you ask, the more time you have to watch the show in the meanwhile.
I'm very sorry, we do not have time for questions. My apologies. Please tie up with Ben and Tamás in the lunch break.
Okay.
Sorry. Thank you very much. Fantastic talk. Another round of applause. Okay, if I could ask everyone to please stay seated, we'll do a quick changeover, ready for Sid's talk.
Okay.
Okay, next up to the stage is Purohit, who's going to do his VS Code Ardupilot developer environment. Over to you, Sid.
Hello. My name is Purohit, usually known as Sid in the community, and I'm part of Cooperative team, and I've been working on Ardupilot in embedded world mostly for last 10 years, over 10 years actually. So yeah, here's my latest project that I've been working on is an VS extension. And so how many of you guys here actually use VS Code for development? All right, not enough. We need more. Basically, there's a VS Code tool that's been there for quite a while now and becoming quite popular with the developers in Ardupilot and everywhere else as well. It's a project that's very written in a web sort of webby tools like TypeScript, Node.js, and a lot of visual elements are from more modern tools. So it basically is very easy to create extensions for a VS Code, right? And it can be quite powerful. So the idea with the VS Code extension is to basically make it easier for new developers and new people to just come on board quickly and just get onto the real work rather than sort of fighting with their machines to compile the basic Ardupilot project. So that's sort of the goal and agenda with this project, and that's the core principle, but there's more to it that we want to do with it. So I'll try to avoid all the demagogues and just keep it simple and use videos instead of demos. And because I don't have enough time here, so we'll just run through quickly through all the features and all the things that we have in this code extension. Hopefully it's all visible, but we'll see. So basically, this is the old way of doing things where you had this, keyboard bindings you had to launch. So this is the old, like 3 years, 4 years. We wrote the initial version of the extension, and it's just something that is really hidden in the VS Code. So I think most of you are not even aware that this existed for the last 4 years, where you could just type this key binding and have just type cube orange or whatever board plus target name, and you would have this way to compile things quickly. So it's been there for a while. Not many people are aware. So last year, someone came up to me and told me that they've been using it. I'm like quite surprised. I myself have not been using that. So I was like, okay, let's do it properly and make it more neat and easy to use. So on the right, we have something that is a modern interface and how basically it's more available for people to just see and use it. So the first step is what platforms does it support? So most of it, like I think, unless you have a weird and wacky OS system, it's basically supported. So if you have a Debian-based system like Ubuntu, it should work. A Windows plus WSL2 configuration should work. A macOS, ARM, or Intel, doesn't matter. This extension should work fine. And as far as editors go, anything related to VS Code or VS Code clone, the extension should work as well. So Let's quickly run down through the feature sets, the core features that we have available in the extension. So first step is, how do you install in this extension? So whenever you launch Ardupilot in VS Code, there should be a little pop-up on the right corner saying, please install this recommendation of extension, and it'll be like this little thing on the corner where you can click install, and you'll be able to install the extension immediately. If not, you can just go to the extensions bar here and basically search for Ardupilot, and it'll basically take you this dev env. You can just click install, and you should have the extension ready to go. Once you have that installed, the first step you might want to do is either clone, unless you don't have already cloned and you have never used Git in your life, and you want to just get on with the, the installation of Ardupilot on your system. You can just click this clone, and it will basically pull the latest master from Ardupilot GitHub account and clone it into your system, and you'll have that available and loaded into the VS Code extension immediately. Another feature that is introduced into the extension is, the environment validation. I know it is like, a lot of developers are not used to, or especially the new upcoming are not very used to doing command line commands and, even finding the install script, or even going through that whole process of setting up an environment on you can start compiling Ardupilot, launching CTL, and all that stuff. So with this extension, you can basically run down through this list of checklists, which will walk you through all the things that you need to actually build and run Ardupilot in your system. And you can have this, nice little buttons where it fails. You can simply click there, fix issues, and it will walk you through the process to install it right below it in the terminal. And you can basically go through this process for each and every basically tool. Like if you have a Python, you can install Python and have that linked properly, have the all the Python packages that are installed to compile and run, MAV proxy and all that stuff will be installed into your system. All the debug tools that you have, OpenOCD, JLink, you can get all that installed as well. All the right versions as well, because sometimes people get OpenOCD and they are like, they don't have the real feature set that is actually possible with both JLink and OpenOCD, which we will see that this extension also provides. So you can have that all installed into your system very, very easily through this simple list without even touching command line. I mean, you sort of touch, but not really. So yeah, this basically gives you an environment validation process for your system. So it can be actually quite helpful for anyone who is sitting here and have got some systems, some things missing, or especially the Ccache one is the easiest one to miss where you don't have the Ccache set up properly, and the compile times are just huge. Every time you recompile, that can be made quite quick if you have Ccache set up quite properly, and it's all listed in there. So all you have to do is just run down this list and make things happy. So once you had validated your system so the previous one that we showed was for macOS, and this one is for Ubuntu and Windows. So you have similar sort of setup that you have to run through. Build configuration. So let's say you want to build for a board or a CTL or something like that. How do you do that? Right now is you have to sort of type in a command and sort of go through that process. There is no UI field or UI application that can help you or guide you through the process of what's needed. So this is sort of what gives you that ability as well. So everything that you can do on command line, you can do it through the build configuration, but with a better visuals and better experience in terms of UI. Gives you the list of, and it extracts all of this from the Ardupilot project that you have already cloned. So this is not hard-coded, most of it at least. So you can just go through this basically process and have your compilation going straight away, right? Similar thing with the hardware builds as well. The only thing with the hardware builds is you get this nice little MCU targets and all the things that will be used for doing debugging later down the sort of process that we'll see. So you can actually visualize that and sort of check that that's all good. And that's basically the additional thing with the hardware build configuration. So these are the common actions that you usually do in Ardupilot project. So you basically build a firmware, debug, clean everything. So in case something is not right, you have a bad hardware, include errors and stuff like that, you can just clean and start again, upload firmware or run CTL in this case, or do a disk clean which just wipes everything, just gives you a clean sheet. So there's been suggestion of doing a submodule update as well. So we'll add that to this action, and we can add more sort of suggestions as they come to this list as well. So let's say you have a special sort of WAF command you want to run. You have something special command that you want to run. So there's a way to actually override it and save it in this basically workspace. So you can come back to it and run this command the special command that can be, have running some extra things before and after the configure, or running special things after the build or before the build. So this sort of gives you that ability as well. The only problem is it's not easy to debug this kind of situation, so you won't see much options around that. So you'll probably see some, just disk clean and build firmware options. So you have to do some manual cleaning if you have something like this, but it does have that ability for you for people to use. This feature configuration. So let's say you have built a firmware and you want to actually add some new features to it or remove features from it. So we have had that configuration in the web UI for a long time. But unfortunately, to do that on your own machine, it's a real pain. You have to search through this list of, big list of things to be able to figure out what flags you need to set. So here is a straight up easy visualized approach where you can just go through, search through all the features, mark, enable features you want, and it'll just add the specific flag for that features straight up into your basically command line like this right here. You can have the we basically disabled mount, and it'll just show up in the feature configuration. So you can either enable it, or you can just remove this flag entirely from the configuration as well. So it gives you a visual sort of view of enabling and disabling features without going through the list of commands and just sort of there's a lot of hidden stuff you could miss that you can just search through it very, very easily. So that's sort of so that's sort of a nice little thing here as well. And again, all of this is basically stored in your workspace. You can easily go back to it, and you'll have multiple features enabled, disabled, whatever configuration you want. Sometimes people want to do debugging and they don't have enough flash to run the debug firmware, and they have to scan through all the features they can disable. So it just makes all that very, very easy and like a 30-second process rather than a 15-minute process. So that can be quite handy as well. Let's move on to the hardware debugging part. So this is one of the features that has been so far limited to, I would say, maybe 5% or less developers to be able to do step debugging in a hardware. So if you have a ST-Link or a J-Link, it is possible to do debugging, but you have to sort of launch this TUI GDB environment, which most of the users are actually not accustomed to, but most of the people are here actually accustomed to using an IDE type system where you can just do step debugging, place breakpoint in the files and stuff like that. So this basically enables that. And again, across all three platforms, not just Ubuntu, also on Mac OS and Windows plus WSL. And even in WSL, you don't need, a USB IP and all that stuff to connect your J-Link to your WSL instance. It just sorts it out right in the Windows environment and connects it to the WSL2. So that makes it very, very easy. You have all the thread views available here. You have all the peripheral views available here, so you can just easily debug all the issues and things that you're facing in the hardware debugging. So CTL debugging, similar approach. but it runs on CITL, so not much to it in terms of launch. You just launch it, it'll launch it for you. Attach. So CITL debugging attached, so you have a CITL instance that's running. So you have a swarm setup, you have 10 drones flying in your laptop, you know, and you want to sort of attach and debug to them. So this is a way to, it'll basically when you launch debug, it'll give you a list of PIDs that you can attach to with the command line arguments that's been given to it. So you can select and connect to them. And the key part is you can actually connect to multiple drones at the same time. So you can have like 10 drones all attached with VS Code because this is something that is available in VS Code. And you can place breakpoints and stuff like that with, you know, everything at once rather than having like 10 different GDB TUIs open to be able to debug that easily. So this is something that is very, very nice about VS Code as well. Here's another feature, the connected devices. So you can have a list of devices that are connected to your system and sort of you want to launch MAV proxy. So rather than sort of doing a list of, you know, your dev and seeing what USBs are available, it will just show you right there with the device name and you can connect with MAV proxy and away you go. So quick launch, you'll have this, you know, Control-Shift-B option and F5 option. So you have configured this system and you want to just not go back to that, you know, AP thing and you know, click buttons and stuff like that. What you want to do is make a change and immediately build. So you can do that with simply clicking Command-Shift-B. So you don't even have to go back to your sort of system to be able to launch another build. You just Command-Shift-B and you have a build going. And the same thing with the launch as well. So you want to do a quick debug launch and do iterate quickly. As long as you have it set up as launch Ardupilot as a setting in this part. Oh, sorry. So as long as you have it set up properly in your this part in the debug, you have set it up to launch Ardupilot. F5 will just launch your debug session immediately without even going through the whole process. So that's another one of the quick iterations. So when I'm developing it, it makes it really, really quick to iterate between changes and actually running the debug. So this power usage available as well if you want to explore. Best way is to actually read the source code and just go through what is actually capabilities are. But I plan on making a more descriptive information around that. Maybe next year I have a presentation more about how you can power use this extension. So all of this development is actually validated and tested in CI. So you have end-to-end unit tests and you basically run through all the environment validation and compile Ardupilot and just make sure that everything builds in VS Code. So we actually do a launch of VS Code instance in CI and run it with the environment validation, make sure that it actually builds with master and things like that. We want to basically explore and expand that even more, maybe add debugging and all that stuff in the validation as well, making sure this tool is extremely, extremely stable for users to use. Here's a list of features that will be coming. So I won't go through all of that because we are running short in time. So there will be a KubeNode AP-perf design that will be included as well soon, so people will be able to design their AP-perf KubeNode-based modules just by selecting pins, and it will generate your hardware def, and you'll be able to basically quickly spin out your perf modules. So that would be quite handy as well. That's something that's under development. Future plans. So it would be nice to have a lot of more features than what is right now, like having a way to debug Lua. So that would be nice, doing a step debugging in Lua. And maybe there's some way to do it. I have some ideas, and that would be really nice. And yeah, having LLM basically controlling your Ardupilot project and spinning out models and trying to talk to MAV proxy, all in the VS Code extension environment. Very, very nice feature, that one as well. So that's sort of the stuff I'm looking to implement. So GitHub issues welcome. PRs are welcome even more. So yeah, thank you very much. And happy coding. Unfortunately, I couldn't get to every single thing, but yeah. 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 If you have any more questions, please reach out to me after or during our lunch break and stuff. Yeah. Thank you.
Amazing work. Thank you, Sid. And I'm sure on behalf of everybody in the room, thank you so much for all the work that you've done on that. That's brilliant. Okay, so if I could ask you to all remain seated for our next talk, which is Andy Piper with Acro-fencing, AI and Acrobatics with Small Fast Drone. And we've got the 12 o'clock bus is leaving, so for the 3 people that are on the 12 o'clock bus, can I politely ask you to exit now, please? Okay, our next talk, Acro-fencing, AI and Acrobatics with Small Fast Drones. Over to you, Andy Piper.
Thanks, Matt. All right, let's have some fun. So, this is 4 talks in one. So rather than getting into loads of technical details, I'm going to show a bunch of PRs, do a bunch of interleave demos. There might be time for questions at the end, but I doubt it, so please come up and bother me afterwards and I can talk through. My demos and my talk just got more and more and more ambitious, and I thought, okay, I'll just demo stuff. And hopefully you'll enjoy it. And then I've got a real demo after lunch. Okay, quick little bit about me. My background is in software, mainly enterprise software. Been contributing to Ardupilot for about 7 years now. I've got my own consulting company, which I've been running as a sort of side hustle for 3 years now. But now I'm doing Ardupilot full time. So if you want consulting, thank you. I do software consulting, but I've also tuned a lot of drones, a lot of light show drones, some of which you may have seen. So yeah, please get in contact by all means. All right, so what is the problem I'm trying to solve here? Let's go this way. The picture's supposed to appear afterwards. So what I wanted to do was fly acro safely in a natural way. So acro's kind of hard. And so my basic premise was construct a tin can fence, fly acro inside the tin can fence, and then at the fence, normally, with a fence, either you get told something bad happened and you crash, or you switch to RTL or land or something like that. What I wanted to do was bounce off the inside of the fence and then hand control back to the pilot afterwards, and ideally not crash. So this is the picture Gemini gave me. I did actually pay Elon Musk for some Grok Imagine credits, because I thought I could do some amazing videos for this, and they were all terrible. Really, really terrible. Worst purchase of my life. So, don't use Grok Imagine, I would say. But this is kind of the idea. So what do we need to make this work? It's a simple thing in theory, but putting it all together is somewhat complicated. So first of all, this is all going to be done with Lua. So guided control using scripting, using Leonard's guided capabilities within Copter, driven by Lua. The next thing we need is obviously good fence support. There's been a bunch of fence support in Ardupilot in the past, but there's certain additional features that you want. In particular, you want a floor in your fencing because you don't want to crash into the ground. That's the sort of most, the lowest bar if you want, or the highest bar. And you want to have good fail-safes. So obviously you're trying to, or I'm trying to, provide a user experience, but at the same time it needs to be safe, so I need to have real fences as well as kind of my own virtual fences. Lots of testing, more testing. Prefer to crash things virtually than in the real world, which means a great simulation environment. And then also, when you get into the real world, you need to have quite a good real world environment as well. You want copters that are actually going to do what you tell them to do. Time. So I've been doing this for about a year, I want to say. This has become a little bit of a labor of love. Went down many, many, many rabbit holes, lots of patience required, and obviously a lot of propellers as well. Okay, so first up, guided control via scripting. And actually there's quite a good support for this currently in Ardupilot, and these are the sort of guided methods that are currently available. That's sort of a good start. So I was sort of onto a winner with that. Fencing. What about fencing? Well, I don't know whether, some people have seen this PR, so I thought, oh, I'll just add min-alt fencing to Ardukopter. Little did I realize the rabbit hole I would be diving into with that PR. And it doesn't actually show the number of changes here, but this PR went on for months and months and months and months. So I needed that fix. I then wanted fence margins, and we'll see this in the demo. So this is, so you want a solid fence, a fence that can't be breached, but you also want to give the copter time to do things. So you want a fence that's a little bit inside your solid fence, and you want to know about it. So this is fence margins, which is also merged. And then I found I needed to know where the margins were, which is not merged. I needed to record more margins. I didn't want to fall out of the sky. I also wanted copters to react very quickly to fences, so the fence code used to be at a relatively slow update rate, and of course things can happen quite quickly in copters. So I wanted those to be fast. And you know, more and more and more and more and more and more PRs. Whoops. Where did that go? Okay. All right, so let's do a demo. Oh. It's this one, right? I don't know what went wrong here. Okay, so in the corner here, you can see my real flight simulation environment. And that's what we've got running here. And so here is my copter. So this is a fence demo. And if you haven't seen fencing before, let's get rid of that. Try and get rid of that. This one, okay. And let's see if we can get some sound as well. Maybe. All right, so. Mustn't be an RTL. Bombing motors. Doesn't look like there is any sound. Up we go. All right. So I'm going to do this in, so we're in chase mode, so we can follow the copter. And you can see the little, so this is the little GCS output. And you'll see if we keep going up, up, and up, and up, and up. Oh, the min-fence alt is enabled. And now if I try and go down, I can't. The copter stops. So this is with object avoidance. I don't know whether you know in loiter, if you've got object avoidance enabled, it will prevent you, it'll slow you up as you reach the fence and then stop you. And so this is stopping you land, which could be a problem, but we'll see about that. Now, I can also fly forward, and the same thing happens when I get to the edge of the circle fence. It slows, you can see the copter slowing up, and then eventually it stops, and I can't go any further. So this is sort of good fence support. And if I want to land, I can hit RTL, and this RTL is a little bit like my real copter, which you should see later today. And down I go. There we go. And I should have increased the landing velocity, so we didn't have to wait for it to land. All right, so what about margins? So this is, again, fencing, but with margins enabled. So this time, when gyro's inconsistent. Gyro's inconsistent. Pre-arm good. All right, up we go. Not in RTL, up we go again. Armed, okay. So this time I'm going to go up, 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 up. Get above my margin, above my min-alt fence, so min-alt is now engaged. Okay, so now I'm going to fly forward. And what you see is now, you see the margin warning coming up there. And because I've got object avoidance going on, I can't get very close. It's like being on a rubber band. So I can sort of fly up fast to it, and then it gets slower and slower and slower, and you can see the margin sort of slowly stopping moving, and then the thing stops. And then if I try and go down, the same thing happens. So, oh, it doesn't let me go down, but it should tell me where the margin is. Nope, all right, we'll do RTL. Back we go again. All right, so that's margins, and while that is landing, we should go back to the presentation. Nope, that's very confusing. Back to the presentation this way. Okay, so fence margins. So the next thing you want, so you need good fence support. The next thing you want is good attitude control. So when you're flying FPV, you don't want to kind of, if you're turning, you don't want to kind of go like this. You want the camera to stay around in the way that an FPV pilot would expect. Whereas the guided mode control optimizes the thrust vector, which might not be what an FPV pilot expects. So you need to control attitude and yaw, followed by velocity. And this is where the scripting APIs that we currently have are not quite what I need. And so I had to add some functionality to scripting, and in particular to control yaw as you're sort of gaining particular velocity. But then for some additional functionality, I wanted a function here that allows you to set target angle rate and throttle. So it basically gives you complete control over the attitude, velocity, acceleration of the vehicle in guided mode from scripting. So this was all well and good. I needed to do some testing. So I wrote an auto test, and I did some auto testing. And I was going to show an auto test demo, but sorry, Peter, not enough time, so on I move. So what I really wanted to do was testing in real flight. And this is why I've got this real flight computer here. Now, this again was a labor of love. So I started off with a semi-powerful computer and encountered all sorts of issues, which I was told were related to the power of the computer. It was a little bit more nuanced than that, but I upgraded the computer. That gave me some better performance, but there's still issues. So I'm going to show you one of the issues, if I can, in real flight. So we'll go back here. All right. So this is running on current master. I've called this Acro trouble. You'll see why. Okay, and you can see on current master, we've got this sort of refresh rate of about 600 to 700 frames a second. And I am going to fly this in Acro, badly, in FPV mode. All right. So, okay, so this is a bit like what an FPV pilot would see in real flight. Okay, up we go. Should be in Acro. Yeah, we're in Acro. So we can fly around in Acro. We can do a roll. We can do a flip. But if I start pushing it a bit harder, okay, this is not me. I just pushed the throttle up, and this is what's going on. So what I found lots of things, but there are quite a lot of problems with real flight and the update rate in particular of real flight related to the physics of the copter. So let me just land that again. There we go. Oh no, I don't seem to have RTL. Oh, crashed. Oh well. Oh, he bounced off the ground and now he's doing RTL. Very nice. I wish that happened in real life. Sorry? Yeah, need more props. All right, so back to my presentation here. So what I wrote was this new PR, which is enabled stable timing on real flight. So in fact, I did two things. So I created a new model. So the model you're seeing here is a Rhys 255 with some Ardupilot extensions. So I added 3-blade props. I made it 6S. I gave it active braking. And it generally works relatively similar to the copter you'll see later. And it's supposed to be have proper thrust expo. But again, it was sort of real flight is good up to a point, and then the physics seems to start breaking down. And in particular, this deal about IMU timing. So what I discovered was that every time you do an update tick in Ardupilot, in Cittal, it essentially does a round trip with real flight. And that round trip is very, very jittery. Like the time can go up and down. And that plays absolute havoc with Ardupilot's, control algorithms, essentially. So what I did was I basically made the virtual IMU run at a much higher rate so that I could get very, very stable IMU ticks. And I fit those ticks into the update frame that real flight gives me, because I'm sort of running on a fast computer. So what can happen is you get an update frame, and then basically you can do all of the frames within that period between that frame and the previous frame to make sure you get sort of stable IMU updates. And so if we switch back here, all right, so what's my branch called? RF fast IMU, okay. So this time, what you'll see is, so if you remember, it was sort of 600 or 700 frames a second. So here it's like 5,000 frames a second. So I basically split it into sort of roughly 10 ticks per real flight frame. And this allows me to get much, much more stable IMU timing, which then means that the flight dynamics themselves are, okay, here we go again. No, in RTL again. I should know by now, right? Here we go, armed, up we go. Right, so I'm not going to push this too hard because I can probably break it again anyway. But basically what I found was this just gives much more stable, sort of locked-in feel. It's not perfect. It's not like a real copter, but it just is much, much, much more stable. And the other thing I did with Leonard's help was I ran System ID on the copter, and that allowed us to sort of notch out some of the weird gain characteristics of the model in real flight. So I really encourage you to try this. It's not yet merged because there's some issues with Sigwin, but hopefully we can get it merged at some point soon. All right, so Oh, I'm too many computers. I'm making this mistake a lot, so I want to be on the other computer. All right, so here we are. So testing in real flight. So I had my good simulation environment. I had my good fences. We've seen some real flight demos. Then I wanted to move quickly. So in my day job, my past day job, I did a lot of stuff with AI. And got auto test, got real flight, but I found the iteration rate of trying to make changes, particularly in Lua, which I'm not, my C++ or Java is my thing. Particularly in Lua, I found that quite slow for me. And so what I did was I started engaging Google Gemini, which is Google's LLM. And if you don't know anything about, I'm sure everybody knows something about LLMs, but there are good ways and bad ways to use LLMs. And the bad way is just to say, tell me the answer to this question, do this thing. You basically have to treat LLMs like 5-year-olds. You have to tell them the same thing 6 different ways so they don't get it wrong. But they're very, very capable 5-year-olds. They can do amazing things, but if you don't give them very tight constraints, they'll go off and do crazy things. And so the way we solved this at my previous job, and the way I've sort of solved this here, is using this notion of playbooks. So basically what you can do is you can write a document that says, you will do everything, when I ask you to do X, these are the constraints that apply to do X. So take a good example. You're writing Lua. If you write Lua code, you can only use APIs that are in docs.lua or core Lua. You can't make stuff up. You can't say, oh, I think if there was a guided mode function that did this, that would be the right thing. LLMs do that all the time. They hallucinate functionality all the time. And you can use playbooks to basically constrain that functionality really, really nicely. So I did one for Gemini, and I still haven't done a PR for this, but it is a public branch, so you can see what I've got there. And basically, I've got one for paired programming, so how do you write Lua in general? And then I've got one for vehicle control, so how do you control a vehicle and obey the rules. And the nice thing about this is that I can now write Lua using Gemini without any syntax errors, generally without logic errors. Usually it's a sort of interplay between myself and the LLM about very subtle things. It's not about how do I write Lua code to do this for loop sort of thing. All right, so let's try it. So what did I try first? So this was my detour from Acro-fencing. And I thought, okay, I'll do some AI acrobatics. So I know Chappie in the last conference said, oh, if you could do some cool acrobatics all automatically, that would be quite nice. So I thought, okay, right, I'll try that using Gemini and using some of this updated scripting code. And so what I did is I developed a vehicle control library to do flips on a switch, which I will demo later. And what I wanted to do was make it a little bit more subtle than that. So basically, you could use a spring-loaded switch and flick it the number of flips that you wanted in a single sort of instance of the move. And so I used Gemini to do that. And let's have a look. Let's see how it did. All right, we'll switch back to... I think we'll go to fixed this time. All right, so this is going to be, so what the script does is I take off in loiter, the script, when it's engaged, switches to guided, does the maneuver, switches back to loiter, hands you back control. So you can see kind of why I did that given my end goal of acro-fencing. All right, it says pre-arm is good. Let's take off. Up we go. All right, we'll go a little bit higher. Not that I'm nervous about it working or anything. Hopefully you can see the copter there. Okay, so one flip. Up we go. Flip. Down we come. And it breaks, and then it goes back to position. So this was all written. The whole thing was written using Google Gemini. So it wasn't my And it was some of my coding, but in the main, it was written by an LLM with my input. Show you again. 2 flips. Up we go. 1, 2. Back down we come. Brakes, and then it moves back to position. And just so I'll demo this on a real copter after lunch, but just so you sort of understand the physics of what's going on here, the idea is that we basically give high throttle input, and we want to reach a sort of escape velocity such that when the throttle is dropped, there is enough time to do the number of flips that you want before you fall back down to the same position, at which point we'll apply the same throttle input. And then hopefully that all works out and the copter's in the right position, but generally it's not, and then we'll use attitude control to sort of bring it back to where we want it to go. So I can do 3 if I want. We go. 1, 2, 3. Down it comes. Brakes. And the only problem with this is what we discovered was the copter is quite floaty in real flight, so it turns out that the throttle setting is way too high at minimum in real flight, and I just didn't have enough time to retune it and all the rest of it. So switch back to RTL. Ah, yes. So the library itself does allow you to do roll or pitch, and I wanted to do exactly that, but time was not on my side. Okay. And I can probably just show you quickly in VS Code. So this is my playbook. And then you can see somewhere here, I've got a module, got this vehicle control library, and it's pretty complicated. You know, we've got like 650 lines of Lua written by Gemini, and then I've got an applet flip on a switch here. Again, that's calling that library. Another, 344 lines. But the experience for me was amazing. Like, I could really just iterate through my vision of what I wanted to do rather than just getting caught up in the vagaries of sort of Lua syntax or anything like that. Okay, so AI acrobatics. So it worked pretty well. And so when I went back, I'd sort of developed my acro-fencing code up to that point, and then I got Gemini to review it. And Gemini said, yeah, it looks pretty good. I think that's good. So I was happy at that. Who believes in LLM these days? But it worked pretty well. And the nice thing about it was I was then able to use Gemini to add other features that I felt were necessary from a sort of safety and usability perspective, but which I was sort of running out of time. So I added a loitering at home feature, which we might see. I added an auto takeoff feature. I did a max alt failsafe, because I also discovered, as well as not wanting to crash, you can actually, if you've got the throttle too high, you can just take off to the moon and the thing doesn't come back. So, all right, so back to the actual aim of this, which was acro-fencing. So back to the demo. There we go. All right. So I'm going to do this in loiter well, to save my piloting skills a little bit, but just to make it a little bit easier to show what's going on. This is an older version of the code that I didn't want to mess with, but I discovered some fairly significant issues with this in the testing earlier in this week, which I've sort of fixed in the real thing. But I didn't want to go back and redo all of my demos. So, okay, so pre-arm good. So I'm going to enable acro-fencing. So you can see acro-fencing on there in the corner. And if I arming mode, and then you can see it says raise throttle to take off. So I raise the throttle, and the thing shoots up into the sky. Let's do on chase. That's probably a bit easier. Okay, and then when I get to the right height, okay, so now I've immediately breached the min-alt fence. It stuck me back in guided. Let's reduce the throttle a bit, see whether I can come down a bit. Okay, 144, 133. Okay, so you can see it says pilot back in control now, so I can now fly this around. I can head towards the fence, try and keep my height decent. So this is a circle fence I'm flying in. And when I hit the circle fence, you can see it flip me around, gives me back control, it says pilot control, and back in. So I'm now in control now, I can fly the thing. Oh, there I hit the min-out fence, so you see I bounced off the bottom. So I need a bit more throttle to keep me away from that, back in control. Oh, flips around because I hit the edge of the circle fence, I think. All right. So I am in control now, but you can see it's a little bit sketchy. All right, so bring it back for RTL. Yeah, it's a shame the sounds aren't working. My wife hates the sounds, but I feel it gives it a bit more realism. All right, I'll let it land. Very slowly. Okay, landed. Right, turn off acro-fencing, back into acro, turn on acro-fencing. Right, so I'm going to try and fly this in acro in chase mode, which I find a little bit, Please don't tell me how bad my piloting skills are. I know. Here we go. Raise throttle to take off. Okay, so we're going up. Right. Okay, so I'm in acro now. So I'm going to try and fly in acro to the fence. I'm getting too high. Let's go down a bit. Oh, and there, it's flipped me back around, put me back in control, and I can fly again. I should be able to do flips still, yeah. Keeping the fence, should be able to go around, yeah. Now I'm really getting confused. But you get the idea. So, before we crash, we'll hit RTL, go back to the presentation. Oops. Okay, so I did all of that virtually because I didn't want to crash copter after copter after copter. I then finally got to try it in real life. And it was pretty scary at first, I have to admit. It was, very scary. But it actually worked pretty well with some teething issues. I had one issue where the trim wasn't checked on takeoff. So I've got this like raised throttle to arm thing. And the function I was using didn't, I think it took trim into account, and I had trim set at the midpoint on throttle. So to get raised throttle to arm, I had to go past the midpoint, at which point the thing shot up into the air to about 100 meters. So I fixed that bug. The other thing I found was the messages, and they're in the OSD, they're not super obvious. You kind of want a bit better OSD integration so you can see what's going on. And the fence messages can get a bit spammy. But on the whole, it worked okay. So I've sort of called this small, fast drone, and my plan is to sort of progress this, maybe build some drones with this capability, sell a few of them, hand-built, hand-tuned, pre-configured. The issue is, of course, that it's quite dangerous doing the testing. I don't want to do this with some, I don't want people doing this with some enormous, well, I suppose the Callisto might be capable, who knows? But the vast majority of drones are going to struggle with the level of control that is required for this to work well. And particularly on an out-of-spec vehicle, this relies on guided mode at high speed working really, really well. Your GPS needs to work really, really well. There are lots and lots of things that can go wrong. But has been quite successful for me. I plan to keep iterating, do more acrobatic moves, and see where I get to. Now, I'll take questions. My initial plan was to do Gemini with audience participation and see if we could write a Lua script using Gemini, but I think that's probably overly ambitious, so I have got a couple of minutes for presentations. So, questions, sir?
Yeah, I can confirm it does look scary when you were testing it earlier in the week. But no, so when you're bouncing between the fences, is there any chance it can like bounce basically between the two bounces, between the lower and the outer?
Yes. Yes, and in fact, the testing we did earlier, so the interesting story, which I've told to a bunch of people already, but there was a bug that I was chasing earlier in the week, which turned out to be Lua's. I was writing my own log file using Lua, and it turns out that the implementation of that, for whatever reason, is really, really bad. And so what was happening was I was hitting the margin fence, and then 5 seconds later, the script would wake up, notice, and flip me around. But by that time, I was way beyond the real fence. And it all came down to this issue with writing your own log file. So I switched to Ardupilot logging, and that completely fixed that issue. But the problem was, what happened was, it was bouncing outside the real fence, turning around, and then bouncing off the outside of the real fence, and then going off into the middle distance, and yeah, so a little bit dangerous. Pete said, whatever you do, don't fly over there, and the first thing that I did was fly over there because it bounced off the wrong fence. So yes, that can definitely happen. No more questions? Oh, Randy.
Yeah, really, really great. I was just wondering, like, about the decision to flip the vehicle around. I would have thought, I'm not an FPV pilot, so maybe that's totally natural for an FPV pilot, but, for the regular loiter fence, we just stop at the fence and wait there, or stop the user from traveling any further. Can you just tell me a little bit about, or tell us a little bit about why you decided to flip the vehicle around instead of stopping at the fence?
Because I wanted to, so the idea of this is to actually be able to fly in Acro. And so I wanted people to sort of just be able to blast around in Acro and not have to worry about where the fence was, essentially. So that was my way of saying this feels more natural than just stopping, but that's certainly possible, certainly possible.
I think one thing to bear in mind, Randy, is that often the camera angle's tilted way up on these, and so if you come to a stop, you can really lose situational awareness, especially if you start backing up too to get back into the fence. So, like whipping around keeps you seeing like
right.
the horizon level.
Yeah, you'll be looking up at the sky.
Yeah, so you don't suddenly, have to reorient yourself.
So I was curious from like a user, when you breach the fence and then it kicks control back to you, does it change your mode back out of guided, or what does that look like?
Yeah. So it saves, it records the mode you were in, it flips into guided, does the maneuver, and then flips you back to the mode you were in before when it hands back control.
Let's say you were doing a backflip into the fence and you hit the fence upside down. Does it flip you away from the fence and then leave you upside down, or how does it exit that maneuver?
Badly, probably. So a lot of the testing I did, I had to add all sorts of fail-safes, like if you don't achieve the attitude and velocity vector, give up, RTL, go back. So one of the things, so a couple of the features I did, which actually we didn't see in the demo, but one is if you take your hands off the sticks, it will flip you into loiter and just park you there until you put your hands on the sticks again, at which point it'll flip you back into acro, and then you can fly around. And then the other one is, yeah, if all else fails, it does an RTL, but it doesn't do an RTL on land. It RTLs loiters above home, and then if you take control of the sticks again, it'll allow you to go back into acro and fly off. Because what you don't want to do is it just keep landing and having to take off the whole time. But yeah, generally, if things go wrong, RTL is my friend, and yeah, handle things that way.
Fantastic. That was an incredibly slick set of demos, Andy. That's brilliant. Thank you. Another round of applause, please.
Thank you.
Okay, and now we're on to lunch. And just a gentle reminder, if anybody hasn't signed the banners over there, if you could kindly do so, it would be very much appreciated. Enjoy lunch.
Join us again later for more from APDC 2025.
Okay, ladies and gentlemen, can I ask you to please go out to the takeoff and landing area to see Andy Piper's demo? Please head out to see Andy's demo.
We will shortly be resuming APDC 2025.
It'd be easier for me not to, like when I do, I'll fly. What if I give you this and then take it? Yeah, that's probably. Yeah. There we go. The first demo, I'll just do that. So the second demo will be. Actually, the first demo probably did help.
This code.
I know, but yeah. More the camera.
You ready? Okay, I'll give thumbs up to Andrew. Yeah. Looks good.
Wherever's good for you. I'm happy forever.
Okay. He's going to do demo for his
Thanks, Matt. All right, so I'm going to show two demos today. One is the flips on a switch, and I'm going to do that first because I'm pretty sure I won't crash the vehicle. And then the second one, I will do the acro fencing in loiter, and if that goes well and we've got enough time, maybe I'll try the acro. We'll see. So just a little bit about this demo. So the sort of the approximation that I've made with help from Leonard and others is that when the drone is in a stable hover, it's got 1 G of thrust. And so there's a configuration parameter that says how many Gs of thrust you want to apply to get that initial burn. And basically it multiplies the throttle at that hover to get that thrust. I can't use the actual hover throttle that's learned because it's too high. That sort of bottoms out at 0.125 and this hovers at 0.09. So I have to configure that as well. So this is configured for 2 Gs of thrust. And I'll do 1 flip, 2 flips, see how 3 flips go, and then take it from there. All right.
All right. So one of the problems with it is that
Yeah, seems to get very, very upset between flips. And so there's sort of a time limit on how much it's willing to accept before it's finished. I'm going to take it out a little bit. Go up a little bit.
okay. So this hopefully is 1 flip. I'm just going to flip the switch once. All right. And then it should navigate back to the starting position. I'll actually read what my error message says. Okay, so we'll start a little bit here. 2 flips. And then,
So one of the things it's doing is the flip itself is rate only, so we're applying a rate and sort of calculating how long you need to apply that rate for to get the number of rotations. And then when it detects that it's passed the 180-degree point on the final flip, it returns to attitude mode, and that's the one that brings it in for this very abrupt
final thing. All right, 3.
Do I dare fall before I switch to the other demo? Yeah. All right.
Beautiful.
And at that point, the EKF is very upset, so I'm going to bring it back, put a new battery in, and try it again. So I have to reconfigure this so the sprung-loaded switch I'm using is using my e-stop switch. So I have to switch those over. But for the other demo, I definitely want e-stop somewhere where I'm familiar with, so I'm just going to reconfigure the battery. All right, am I back on? All right, so this time I'm going to do the Acro-fencing code. So I've set up a poly fence all the way around the field with a flip for the houses at the end. It's approximately where the fence is, and then the margin fence is set 40 meters in, which is kind of at the end, just beyond the end of the landing pad. So what I'm going to have to do is walk out beyond the margin so I can take off, otherwise it just kind of spams me the whole time. What I'll do is I'll fly, I'll take off. You'll see it does the auto take off. I'll then fly towards this boundary over here, and hopefully it should flip me around and put me back into the field, and we'll do that a few times. Can you see, is the video coming out on the screen? So you should be able to see what I see in the FPV goggles. Sorry? And at this point, I might lose the mic just to not tempt the demo gods. I'll probably need a spotter. Yeah. Do you want to be a spotter? Right.
I think it's off now.
Just trappy. I can't see.
Don't worry. Don't worry.
Sorry? I'm going to move the copter out. So I'm just going to move the copter out beyond the fence.
Helicopter in the distance.
Randy, you see the copter, right?
Yeah.
Yeah, we see it. It looks like it's heading south, so.
It comes towards you, I would scatter.
Everybody wants you to know there's a copter.
Sorry?
A copter.
Yeah.
okay.
It's heading south. I think it's not coming any closer.
It's all right.
You're gonna sit here?
No, I was just going to say something. Do you want to? Can you just pass me the mic?
Yeah.
Sorry. Yeah.
Yes. Okay, so I'm in Lloyd's here, which you can see. I'm going. Yeah. Right, checking e-stop works. Right, I think we're good to go. So I'm going to enable Acro-fence. It should be this one. And then I also have kill scripting on a switch in case things go horribly wrong. So no safety issues. Friday. Can you get inside now? too close to it.
Well, I think it actually breached this way. It isn't allowed for it to come on. It's my fault.
I took it too close to us, so you breached this direction. I should have done better. It's landing where it took off from. This is the right thing to do.
Thank you.
No final words, right?
Huh?
No final words, right?
I would just say finally, you could see there was an EKF lane switch at the end there, and the EKF was very, very unhappy as it came in, and that was why we were sort of getting it going around like that. So this is slightly the problem with this is you've got to have very good GPS, you've got a very good compass. The EKF has got to be very, very happy, and even then, it feels a bit like you're sailing quite close to the wind. But you know, I've shown it can be done. So more hacking to do, but I'm quite pleased with that result.
Okay, thank you everybody. If we could head back inside, and then we're going to start with Hamish on the MAVLink report to document. Thank you.
Okay, everybody, if you could just please take your seats. The next talk is about to start. Please take your seats.
Thing is,
Okay, next up, we've got Hamish, Willee, and James Patterson with the MAVLink report. Over to you guys.
Before we start, just because we're right near the end of the third day, and whilst the last session is Matt and Ben and Co saying thank you to everybody else for the effort that's been put into pulling this together, before we start, we just want to get Matt and Ben and Michelle, if they're around, just to stand up. Yeah, come on, stand up. And Pete, come on. Yeah. And just for everyone here, just to thank these guys for the effort they've put together in pulling all this.
And also, all the team members that helped out. I've been to a lot of these sort of events over the years, and I don't think I've ever seen such a friendly and helpful staff who are, you know, not just willing to answer questions, but friendly with it and not trying to get away too quickly. So thank you all as well.
So with that out of the way, now we'll get on to the interesting stuff. All right. So I think everyone in this audience knows what MAVLink is. Some of you will have engaged with it more directly than others, but everyone is using it if you're using Ardupilot or Mission Planner or MAVProxy or any of the tools that we use. The presentation that we have today is basically a reduced version of one we gave 2 years ago. That might sound a little bit boring, but it's actually something that we deliberately do within MAVLink, which is control the rate of change within the protocol. It is such an important API that if we change it, we can break things very, very quickly. So yes, it might not look like we've done much, but some of that's deliberate just so that we do maintain some stability in the API. The link's on the page there. Best resource, if you can get hold of him, is Peter Barker for implementing MAVLink. He'll hate me for saying that, but he is great. And I only say that because you can never get hold of Tridge, who would otherwise be the best resource for implementing MAVLink. All of those things do evolve slowly over time. Hamish puts a lot of effort into maintaining them. A lot of people throughout the community support that. If you do have questions on those things when we get to the end, noting this is only a 20-minute session, then we'll do a little bit of Q&A, but I think that most of those questions are going to be focused on the next couple little tidbits that we're going to go through.
Yeah, so when you're contributing, I guess the thing that, leading to the fact we did this a few years ago and had this talk, most of the things are the same, and most of the pain points are the same. So we are going to go over this again. Common.xml is where most of the messages have historically gone. And it's a bit of a misnamed thing because there's a lot of stuff that isn't common in there. There's a lot of stuff that's never been implemented anywhere, but we don't know what it is. There's a tendency for people to contribute things that they think everyone will want that turns out that people don't want. Am I skipping ahead, old slide? Probably. Anyway, best I should just read it. Okay. If you're contributing, please contribute into Common. If you're contributing, please first put it into MAVLink repo. Obviously, you may need to discuss it, and this happens quite often in the Ardupilot community first. But because we do want it to be common or as close to shared as possible, we definitely want to make sure that we can bring the people in who will say, no, we don't want it. And it's similar when you're working in the other communities. We want to make very sure that Ardupilot is going to welcome an idea is good. So first up, well, MAVLink. But if you are making changes in Ardupilot.xml, Ardupilot.xml, do that in the Ardupilot MAVLink repo. And I pull that up automatically, verbatim, every couple of weeks via CI, which can break things. Quite exciting, living on the edge. And the last thing here is custom dialects. We talked a lot more about these last time, so if you want to find out more, look at them, go and look at the old talk. But the main point here is I don't encourage them. It's a maintenance burden if you use custom messages. Obviously, if you have to and you don't want to work with every GCS that's out there already, go for it. But you'll be much better off if you can work through the slightly torturous process of working with us.
The key reason, obviously, sometimes there's good reasons to use custom dialects and manage those things yourself, but one of the key benefits in having a standard API such as MAVLink is interoperability, and if you go and vary from that through your own implementations, then obviously you lose that interoperability. If people do want to be doing their own dialects, again, that might be just a sidebar conversation that we can have as to how to manage that. The key thing is that if you are going to do it, reach out to us, reserve a message range so that you don't conflict with anybody else who's using custom dialects as well.
Okay, so for the last 6 or 7 or 8 years, however long I've been on this, we've been trying to have some sort of process for managing change. That process is currently we will allow semantically non-breaking additions, and we oppose pretty much everything else. That'd be fair. And we've tried at various points to put in some sort of project management. We've tried to put in some tagging. Some of those PRs have been sitting there for years. None of it's absolutely vital, but it would be nice to get some of it in eventually. And we now have a new and cunning plan to reach closer to some kind of management and to break some of these pain points that we've got where people want to get things in common, but we can't. We know they're probably not going to be common for a very long time or standard for a very long time. And we're not planning on taking anything that couldn't be standard, but we would like to be able to take things that aren't going to be implemented everywhere straight away. So what we're doing there is, where's your button? Yeah? Find a button for me, please. Is that we're going to move as much as we can from common.xml into standard.xml. That means the things that are either truly common or can be made truly common, and we've started a little bit of this work, and mostly working with Peter. Processes essentially we chat about what we think might be common, we do a bit of testing, we then synchronise MAVLink and Ardupilot MAVLink for the set of messages that we want to move in, and then we move them in all places at once across. And we're hoping at the end of the process that we'll have a relatively, a much thinner common and a much cleaner, a clean standard where people can look at that and say, yeah, this really is standard. And if it isn't standard, we know which bits aren't standard. We have discoverable ways.
So I guess pulling that into the framework that we've been building out over the last few years. So we brought in minimal.xml probably 4 or 5 years ago now.
I think, yep.
Minimal.xml, to give the minimal implementation of what you need to participate in the MAVLink network. Standard.xml has been part of the repo for a long time, but it was just a single line include of common.xml. We've flipped that around, so that common now includes standard rather than standard including common, and started moving those truly common messages into standard. And that, the intent there is so that standard.xml, when paired with minimal.xml, will give a truly common implementation of a basic MAVLink participant.
And we're planning on being pretty hardcore on that. Yeah. Okay.
Now, we haven't updated this for 2 years. We're going to talk to it. We have actually evolved this across the course of the last week as far as the thinking there. So this is probably where the conversation is going to go, noting it's already come up twice today and a number of times earlier in the week, but about basically moving MAVLink forward to deal with larger networks. You've seen one example of why we might want to do that through the light show discussion earlier today with the 255
nodes.
Yeah, participants for system IDs. The other reason that we get asked about this regularly is not just those large activities like a drone light show, but some companies that want to manage large fleets with basically unique serial numbers for each of their drones, whether that's a large operator or whether it's a vendor that wants to be able to uniquely identify their drones. So there's quite a lot of pressure from different parts of the industry to fix this, and that pressure is kind of increasing pretty regularly. What it's going to look like is not actually this RFC completely at this point. It's the intent is to move to full 32-bit addressing. So if you wanted to, you could put a full IP address in there, although it won't be necessarily tied to IP addressing. And the intent there is to basically start working on that very, very quickly. And thanks to Tridge for putting forward this RFC and being part of those conversations since, and B, volunteering to do all the work. So thanks. But there's going to be quite a lot of tooling change with that, as well as just the actual design.
I'd like an aside here. I think people have been asking about this for a very long time, and I think maybe the RFC went in from Tridge 2 or 3 years ago. At that point, everybody was kind of, yeah, this is a really great idea. You know, there's some issues that we're not sure about, need some prototyping. The MAVLink team, us and a couple of other people are involved, don't do work, okay? We have meetings, we discuss, we try and collaborate and bring people in, but the actual implementation of anything into MAVLink has to come from you and other members of various drone communities. So this is the main reason this has been waiting, because it did require an implementation, and so it's quite exciting that we're now here. If there's something you see in an RFC or a message that you're interested in, don't just sit there and think, oh, it'll never happen. Come, ask us who's responsible, what can we do to move this forward? Because the people who can do the work are often, you know, their time is stretched. So you need to come and make them aware that this is important to you too, and maybe they'll outsource some of the work to you.
Yep. Yeah, that was coming.
This would be great. What can we do to move it forward?
Tell Tridge to work harder, not smarter. Tridge, would you like to say anything about this?
Yeah, prompted by the light show talk, I've actually started a branch and started working on it, and it decided to do the, after my RFC years ago, it's going to be, I've decided to go 32-bit system IDs, just because in the sorts of environments we have that many vehicles, the extra 2 bytes isn't worth saving, and the simplicity of being able to map IPv4 addresses directly into system ID is worth it. It will be a little bit of an API change in the code to do the target systems, because the target systems are in line in the message structures. And so what I'm doing is there will be some new little methods that Ardupilot will be using. When it needs to set the target ID, there's an extra little API wrapper to be able to set the target ID on a message. But it's going to be backwards compatible in the sense that it's the same code running, and as it's constructing the packet to put it on the wire, if the system ID that it needs to put in there is 255 or less, if it fits in 8-bit, then it will be a current MAVLink 2 packet. But if it's more, then it adds the extra incompatible flag bit in the header, which says this is the new one, right? So it will mean that only those who are actually utilising IDs greater than 255 will be paying the additional cost, and that keeps us completely backwards compatible with the existing ground stations and tooling. And because of the semantics of the incompatible flag, even mixtures of ones that understand and don't understand should work, where a ground station that doesn't understand these new messages just won't see the messages that have IDs that are outside the range. So that's the plan, but we'll see how it works out.
Will you still pull the header out of the payload, the target stuff out of the payload as a compatibility, as well, I guess it has to be an incompatibility bit even below 255 or whatever? Because I know that routers and whatever would like to be able to parse those messages without passing the CRC extra check.
Yeah, I haven't decided whether I'm going to include the CRC extra part of the RFC. I'm going to see how that works out. My inclination at the moment is not to change the CRC. This was trying to address two separate issues, and given how long it's taken to get an implementation, they can be addressed separately. So my inclination is to address the 32-bit wide system ID separately from the routing issue. The routing issue comes up when you've got like an RFD 900X and a new message gets added to the message set, and without that CRC, it has difficulties in the routing task when it wants to route within, say, a mesh network. But I think I'll do that as a separate task, so to not hold up the one that more people need right now, which is the 32-bit ID.
Thank you.
Right, who's next? We might as well we seem to have jumped straight into the Q&A question bit, so let's just do that. And we'll close with that. There's always, we do need more help. More participants, more testing, more contribution, and I think that's a common theme through most open source projects. So if you're interested in MAVLink, then please just reach out, get involved, turn up to the dev call. MAVLink dev calls are only every 2 weeks, and we basically lock them on a hard hour, so it's not too huge a time impost, and it is a Europe-friendly time for that call.
It's not a dev call, Ardupilot dev call friendly time though, is it?
No. So if you do the Europe Ardupilot dev call, you kind of can't do the MAVLink dev call, they're at the same time. But apart from that, it's a good time for Europe and for Australia. Any other questions? There's got to be some.
I'll ask us a pretend question. One of the other ones that came. Okay. Yeah.
I don't see Discord up there. Do you guys have a Discord server?
There are Discord channels for MAVLink in both the Ardupilot and the DroneCo Discord servers.
Okay.
Oh, and also the DroneCan Discord server, there's a MAVLink channel as well.
Yeah, there are 3. I monitor the one on the PX4 area, and I look for my name tagged everywhere because I don't get messages unless I'm specifically tagged anywhere on Discord. I think it's an abomination. Yeah, if I'm tagged, and I will answer, and I will chase things up for you, and James is actually busy everywhere as well. So yeah.
But the dev call or tag an issue, yep.
GitHub?
Yeah, that's what I meant.
Yep. Okay, so the other one that came up was the parameter protocol, having the ability to report errors. I haven't been really much on Git in the last 2 weeks, but Peter's already put in a PR. I've looked at it. I'm not sure whether it was in development or tagged WIP, but aside from that, I haven't run into anybody who doesn't like the idea, so we will probably just rubber stamp that once we've made sure we've got the proper agreement. And then it will be implemented as soon as Peter works harder and not smarter. When will that be?
I'm still working through it.
Fair enough. If that's all.
Super. Thank you very much. Round of applause, please. Round of applause. If you could kindly all stay seated for a quick changeover. Next up is Alexander Sandström from Remote Aero.
Should I go?
Okay, so take it away, Alex, for your talk from Remote Aero about light fixed wing aircraft for early situational awareness.
Okay, hi everyone. Oh, it started raining. Yeah, so I'm Alexander from Remote Aero. You might recognize me from last year, where I did a longer talk on our project with the Swedish Sea Rescue and how we provide early situational awareness for them. If you missed that, I'm going to do a quick debrief and then talk about some stuff that we're working on right now. So Remote Aero's initial use case was with Sea Rescue to provide early situational awareness. So essentially give the people in the control center as well as the operators on board more information to take better decisions. So essentially that they know what they're facing and they can optimize their resource use efficiently. So the Swedish Sea Rescue has a very ambitious project now, putting these launcher fixed wing systems all across the Swedish coastlines and in the big bodies of water. Currently there's just one in Gothenburg, but slowly getting there. We've also seen other potential use cases for this. We've been in contact with other land-based rescue services, ambulance for incidents, etc. But we do see that the use for these types of systems could be used, could be like remote infrastructure inspection after a storm, or any of the sort for municipalities, or anywhere time you need to drive far off to get some quick piece of information, or do something dangerous or dull, but we could use a fixed wing instead. We've seen an immense growth in the company from going to 2 to 4 people since last year. Here at the conference, we have me and Filippa representing us. And back home, we also have Björn Bringert and Fredrik Falkman. So this is the plane, which you might recognize from last year. It's a Delta Wing, coming in at about 900 grams. The first one has gotten a new friend, so we now have 2 planes in the fleet. Our longest recorded flight is about 78 kilometers, which we did in about an hour and 24 minutes. More of like a long, slower mission, but we returned at 40% battery, so we're pretty, theoretically we can reach at about 130 kilometers before, going down, I suppose. It's made to sprint fast, so it has a top speed of about 30 meters per second to get out to the situation as fast as possible. And we fly over the mobile network to allow that kind of range. So essentially we've been operational for a few days now, since the two weeks back, where we had operational readiness, you can say, for real distress signals at sea. So this is what the offering looks like from the operations center point of view. So they send us a coordinate or a rough location that they get from the one calling in distress signal. And then we handle everything related to the drone and sending it out, flying it out there, and then we send them back a shareable link on email, so they just have one click to get authenticated access to the video feed and the telemetry stream, etc. So now over to the things we're working on. So now that we've seen the sort of drone operation from end to end, it's all about getting the best image we can from a fixed wing, which is quite a challenge. So at the moment, we're using a custom-made servo gimbal, which weighs in at about 50 grams. It works fine, actually, but it becomes a bit of a bottleneck having to do this finicky construction with each new drone that we do. So we'd gladly, we have been out there testing other lightweight gimbals, such as those Randy was presenting, or like similar to the one that Randy had on his drone earlier. Some of them, we've had quite a bit of issues during the testing phase because they usually have hardware roll limits at about 30 to 45 degrees. And it's usually not that they just hit that roll limit and then when the plane levels out, they level out, but instead they start acting a bit weirdly. And we've had a few of them bricked for firmware updates, and they do like these weird dances sometimes when occasionally when the roll limits are reached. So we're working, this is a screencast from our web-based GCS that we were using with the live video feed at the top and the map to the left where we just right-click and choose in the context menu if you want to fly or put a POI or like a point of interest or region of interest. And then to the bottom right, we have the history view where we scrub back into the history or in the video feed if there's anything that caught our eye before. So to do this, well, we've tried to optimize this a lot, worked with different modes of the camera. So we're using GStreamer, so we've used that to, like the base mode is the 1080p at 30 FPS, but then we've also tried to dial down the frame rate to get high resolution imagery, which makes it much easier or much better images when you sort of pick them frame by frame and try to show them to someone. We've also done like uncompressed stills, so we use the full resolution of the camera. That requires that you change the camera settings, so you go dark for a while to do that, but you get really nice images, and we believe some sort of burst mode may be the thing to go for here. And then, of course, it's all about how the picture is used in the end, or the image is used in the end, so that's sort of guiding our process in all of this. We've also put a lot of work in remote landings because our pilots can be anywhere in Sweden, really. So in our interface, we've added support for right-click landings. So this might be important if, for example, the search and rescue helicopter enters the area where we've been taking images. We need to put the drone down fast. So here you can see the pilot laying out the mission, like an auto mission with a landing. And it gets like positioned into the wind automatically and some assists in that way. Remote landings makes us end up in undesirable places sometimes, but it usually leads to good learning experiences. So this was a good test for the waterproofness. So after this landing, we took it through our bespoke drying facility, and just 12 hours later, it was back in the launcher again, ready to go out. So that's been a good test. Now over to a very exciting development that we're doing. So essentially, when we talk to a lot of rescue services using drones today, mainly DJI drones within line of sight, they're usually they've started gravitating more towards lighter systems because one of their biggest expenses and time sinks is training both the pilots and the people watching the image. And of course regulations. So they don't necessarily want the biggest and best sensors because for example, with an IR camera, you have to train both the person taking the image and the person analyzing it to what that does. And this gets, with a big organization, this becomes very cumbersome to maintain. So that sort of led us to this very highly integrated, with a highly integrated drone with a very specific payload, being just a camera, like the RGB IMX sensor currently. So this is a terrible illustration by me of the Swedish countryside. But here we also, on the regulation side, we plan on flying it really low. So we think we can achieve, with a minimal ground risk of a 249 grammer, we can fly really close to the ground, effectively separating us from other airspace as well, where other aircraft and drones might be. So this was initiated this spring with a master thesis student who did some great models that he flew. So the first one was came in at about 300 grams and had a top speed of 25, which is also the limit of a 249 gram drone to go under the 80 joule limit that they also set. The estimated endurance was around 48 minutes, and which gave it a range of about 32 kilometers. Those are like preliminary numbers. Parallel to that, we took the RC test flight and think flight flick wing that they developed, and we bought that off the shelf and equipped it with the full stack from the 900 gram airplanes. So flew that with 4G and no gimbal, but 2 fixed IMX sensors. So one to the front and one facing inwards in the loiter. So we would get images instead of having to turn the gimbal. This is now at 283 grams, so we still have some work to do there. But it has the same top speed, and yeah, roughly we're aiming at 50 minutes of endurance. We'll try to shave off even more weight to make that longer. Some of the steps we're currently working on are is a lightweight carrier board, so shaving off grams of the previous generation, so that we can get down to the limits that we need. We also want to do, obviously, our own frames with like injection molded or something like that. So that also, we aim to save a few grams there. Flying this close to the ground obviously involves terrain following. So we haven't, since we've been flying over the sea for a long time now, we haven't really been totally accustomed to that. So but we have flown this 283 gram version with a LiDAR, which has worked really well during landings and such. So some type of software image stabilization we're looking at to ease the burden on the pilot especially, as well as to maybe extract like high resolution, more focused imagery from the otherwise quite wide-angled camera. This is the current launcher you see bits of here, which is like a long Pelican case, but for the small one we don't need this much power at all, so it would be more like a carry-on bag is our end goal there. And we're also looking at a tail-sitter version, which would improve the landing procedure a lot, or make it a lot easier to land. And also, because we can't always, loitering around the place of interest will result in you having temporarily the image you want, and sometimes the sun is in your face, or there's obstacles in the way, etc. So with a tail sitter, you could potentially fly out and be still for a while, get the image you want, and send it onwards. Thank you so much, Cage, Hanman, Peter, Matt, and the rest of the 3DXR team. Thank you so much.
Hi. So, is there a reason why you aren't doing hand launches?
Sorry?
Is there a reason why you aren't doing hand launches, like throwing it up like a boomerang or something?
Yeah, so, I mean, we have done like shake launches during testings and stuff, but we have The launchers can be equipped with like a thing that it's like a thing that opens locked cabinets. So we wind it up and we can remotely launch it like through our web interface using that. So the launchers are like to be equipped more with, or when they're placed out there, we're gonna electronically release them. So that's why.
Right. Thank you very much.
And this gives a lot more. I mean, the hand launches are a bit unreliable. So it's been using a catapult has been a game changer for us because it's
great.
It makes it the same every time.
Okay, thank you very much. Another round of applause, please.
Thank you.
Okay, next up we've got Pierre Kancir.
Wrong, sorry.
Okay, just as a reminder that at around about 3 o'clock we are expecting the emergency text alert to come through. When it does go off, if we could please sort of ignore it as best as possible and pay attention to Pierre. Okay, so Pierre's going to tell us a little bit about community and visibility insights.
Hello everybody, I'm Pierre Kancir, I'm French, and I belong to Ardupilot dev team. So I will present you some insight of my wandering on conference presenting Ardupilot all around Europe, because it could be quite far. So, small disclaimer, most of the slides are my opinion, my experience of presenting Ardupilot and getting feedback from people I meet. So don't take it as the absolute truth. So when we go on Ardupilot, we got a wonderful website. We put some time to update it, to fix like the layouts, the mobile version. We got some dark mode now. Everything is going great on this. We're still looking for some contribution. If some people are quite experienced on websites, who can help us on fixing some bugs we still have on the main page. That would be great. We got the wiki. A lot of people already spoke about the wiki, so it's still a great place with good information on everything in robotics. We got a lot of information on GNSS, on compass handling. If you want to make some contribution, you need to pass on validation. Could be hard, but for the greater goods. I'm trying to put some effort to get a faster building on the wiki. Shouldn't be hard, just Python. If somebody wants to help me to maintain the build system on the wiki, it would be great because it's quite hard actually. Yeah, and I want to update Sphinx version 4. So the Sphinx software is what is building the wiki. And we got a recurrent request that is to have offline version of the wiki, or PDF version is not working well. I will try to make it working. So yeah, some issue on the wiki is still growing large, but it's kind of becoming too large, and so a lot of people, especially in e-commerce, can be like lost on finding accurate information on how to get a start on Ardupilot. So we should probably put some new effort on this, maybe some new guidance, some new page to guide or to lead newcomers to how to get it started with Ardupilot. So for the common things, this is a tool that probably not a lot of persons know. We got some analytics on the website and on the wiki, so we can track what people are looking on the website. It's truly great great source of information on what is happening on Ardupilot, because you can see some trending, like what people are really wanting to see on Ardupilot. So there is a generic page. Everything is free to access. It's online, so you can just look at the data. So we can see that we got a lot of people looking at the website. It's quite stable over 1 year. That's great for the project. So yeah, so that's the kind of information you can find. So you can click on every button to see what people are coming from, what people are looking on Google. You can have the top page looked on Ardupilot, so you can see that Mission Planner is still the most looked page on the wiki, and the copter parameter, because everybody wants to know how to set up Ardupilot. There was some also new information. So ChatGPT starts with make answers that send people to a website directly. So that's quite new. It wasn't there last year, so it's quite interesting. And what is also interesting is that ChatGPT explains people how to install Mission Planner. So we probably need to update the wiki page on how to install Mission Planner. Yeah, and so this is more, again, some information we can get. And so we can speak about discourse, because a lot of things happening on discourse, so that's our forum. Yeah, unfortunately, we can have, you may have seen this connecting to discourse. It's happened quite often. What is happening is, okay, we got a lot of traffic on discourse. You can see on blue, it says logged users, so normally people that are contributing. In green is like what discourse said is anonymous user, so it can be non-logged user, it can be bots, it can be anything that connect to discourse. So that's great, that's already huge traffic. And what is happening is like, we got a lot of non-human being trying to grab every data from discourse. So that's mostly ChatGPT, Gemini, Bing bots, and every LLM are passing discourse to make that training, and they are killing discourse. So it's not isolated to Ardupilot. I speak with a lot of other open source projects. Everybody got the same issue with LLM spamming and just knocking every website by just passing them. So just be aware of this. And if somebody wants to help us to put some guards for this, make a contribution, it would be great. Okay, so over the last year, I make some conference on behalf of Ardupilot. I present Ardupilot on some huge conference. So I was in FOSDEM. For those that don't know FOSDEM, it's a community event, mostly on hacking, but they start getting back on getting the robotic field. So I present Ardupilot there last year. It's a great event, a lot of people, and yeah, but it's truly a community event. I was also to some ROS conference, so mostly French ROS conference. For those that don't know ROS, it's a middleware for robotics. It's like kind of the standard middleware for all robotic stuff. It's a great place to exchange with robotic fan, because everybody wants to make ROS and robot with ROS, and so it's a great place for company, academics, and even hobbyists to learn about robotic and learn about new projects, share mind, share experience. I was also at Linux conference. So Linux conference, quite different against the two others, because it's like a big corporate, so there's a big company using Linux. It's still on open source, but yeah, it's quite different from the two others. And I also attend to some other national academic events in France. On those places, it's kind of hard to present Ardupilot, because every people get their own agendas, already make the budget for projects. So yeah, it's quite difficult to put on something. So from this conference, I got some feedback. So generally the first feedback I got is this one. Glad to see the project is still alive. So yeah, poker face. So I also got this kind of feedback like, okay, you're still using Arduino, or I love my APM board. Okay, great, we are just dinosaurs with drones. Also got this one that is like, okay, we don't want to speak about this, but yeah, everybody asked me questions about this. So yeah, we'll pass. We'll remind that we got a code of conduct. It's kind of fuzzy in people's minds, so sometimes I said, okay, Ardupilot, don't deal with weaponized, we don't want to hurt. And 1 week after, we got something on the news with Ardupilot, and people said, Pierre, you lied to me because we saw you in the news. Oh, that's not us. We did nothing. So we should probably make something better as a project to present to stance. Well, that's my opinion. Yeah, but the most important feedback is those one. People don't really know what we are doing and what feature we got, what we can do. So it's kind of sad, actually, because we got a lot of good stuff. So yeah, the project lack of visibility outside people that are in the drone world, in the flying drone world. So you may know we got boats, we got submarine, we got rovers. It's awesome, but nobody knows about it. So we should try to present a bit more Ardupilot. So as a reminder, we got like a blog section. It's really open to anybody, hobbyists, partners. Please present what you achieved with Ardupilot. If you got some projects that are quite new, make a blog post. It's a really great place to exchange with the community, with everybody. I read blog posts. I love reading them, and a lot of people are reading them. Just some attention. It's not for marketing purpose, so yeah, just be careful with this. And if you are not sure if it's fit for a blog post, just ask us, and we will say if it's good or not. LinkedIn. You may have seen that I post a lot of stuff on LinkedIn. So 2 days ago, I posted a picture of a Matt and Pete drone. I got like a few thousand people looking at my post. It was like kind of a joke. So it's a great place to advertise robotics. People love to read about robotics, and especially Ardupilot. So don't be shy and publish on this. It's a great place for kind of professional. So yeah, it's not like a social media for everything, but a bit of warning. So I get some feedback, some companies, some other projects that, okay, our community is great, but sometimes it's a bit too much enthusiastic and say, okay, your project sucks because Ardupilot did it before, or Ardupilot did it better. Yeah, we need probably to calm down. So I got some feedback that some companies were like not happy to learn that they could have just grabbed what Ardupilot have done and not paid some developer to do the feature. So yeah, try to be diplomatic when we're speaking about Ardupilot. Oh, it's concerned me also because I was doing this in the past. And so some opening. So in the recent years, you may have been that Ardupilot dev team grow a lot. So we got a lot of new people that are like collaborating with a lot of new projects. And that's great. I think that we need to continue this effort. So yeah, we got cross-project collaboration, especially with Rhys World. So we got Ryan and Rhys and myself picking a lot with Rhys team and people involved in Rhys. That's great to present a project and get some feedback from other projects. So just, yeah, as a conclusion, just speak about Ardupilot, what we can do, how we can do it, and yeah, just share the world so people can learn that we're doing great stuff. And it's quite easy, actually, to use Ardupilot. So yeah, that would be all for my talk. It wasn't like a small talk.
Any questions? Fantastic talk. Thank you very much, Pierre. Another round of applause. Okay, so next up we've got Ryan Friedman, who's going to give a little bit of a talk to the demo he performed this morning.
Mike.
Okay. So now Ryan Friedman's going to do a talk following on from the demo that he did earlier today about Ross and advanced path planning.
Hello, hello. All right. So I'm Ryan Friedman, and standing here with me is Rhys Mainwaring. We're going to be talking about some path planning we've done with Ardupilot. But first, we're going to talk about cross-compilation. So it's very common for developers of Autonomy to be writing Autonomy in C++. So this is just some initial work I've done to open source a cross-compiler that allows you to develop C++ applications faster when you're targeting typical ARM platforms on the drone. So basically how this works is you write software on your laptop just like you do with Ardupilot. You compile it on your laptop, but you target ARM64, and this will work for Raspberry Pi or NVIDIA Jetson. And then you can copy the binaries and runtime dependencies to the target hardware. So here's just a little hello world. I did MAVSDK as an example, which is a C++ API. To do this, we use CMake, which involves a few steps. The first is to configure, and as part of that repo is a toolchain file that sets up all the things necessary for cross-compiling. So this basically finds all the dependencies for your application, and sets up all the files for the system. Now here's the cool part. The typical way of doing this, particularly in the ROS ecosystem, is to use Docker and QEMU, but that's 10 to 20 times slower than native compilation. So if you don't have time to set up a cross-compiler and you're writing big ROS applications with CI, it can cause your CI jobs to take hours, which is not really useful for rapid development. So with this step, we can now compile using the host compiler and build your targets very, very fast. So once you have those dependencies built, you can install them on the target, and here's running a hello world on the target hardware. So it's very quick, and there's obviously work to do to get it more integrated with the ROS toolchain, so I'm working on that. But at least for simple applications, feel free to go get started and file bugs if the toolchain is missing certain dependencies that you need. Any questions on that before we get into some path planning? All right, so what I've been working on with Rhys for the past couple of years with regards to path planning is sort of this high-level goal of we want to obey fences in Ardupilot, or any autopilot for that matter. We want to avoid terrain, and we also want to be able to respect max AGL constraints that are frequently required by regulations. We'd like it to work in autonomous modes, but also RTL to get home. And we want it to run on board the vehicle, so if you have a GCS failsafe, your vehicle doesn't rely on the ground station to find its way back. And we also want it to be flexible, so you can bring your own constraints. Say you want to import TFRs from your local airspace from your country, you can do that, or other kinds of constraints, you can add them. So currently with Ardupilot, plain RTL, you can't really avoid the fences. It's very easy if you have exclusions that the plane's going to fly right through them on RTL. It uses look ahead to climb over terrain. If there's a very tall, narrow mountain, you're going to climb over the mountain rather than go around it, which isn't very efficient. Copter does have a lot of algorithms that have built that work quite well. But unfortunately, these don't work on plane because plane has curvature constraints. So those constraints mean that you can pretty frequently violate your fences, especially if you're very close to them. There's a method to do breadcrumbing, but that doesn't work quite as well in plane if you use more than half your battery, unless you do some loop elimination, which takes a lot of memory. And finally, currently, the companion computers, we don't really have any libraries built up to share fences between the companion computer and fences and terrain data with the autopilot and make sure they're all synchronized. So what Rhys and I are working on is creating a tool and a framework for Ardupilot developers to build path planning. We want to make deployment easier and basically be able to deploy complex path planners, but really easy to copy it and run it on a companion computer, and support both open source planners as well as commercial solutions, and use this as a way to gather feedback and influence our design. So the first path planner that I integrated was from Shearwater.ai. They make an AI path planner called Smart Flight. Here's sort of from their product page. It uses micro weather forecasting and forecast data. It can optimize based on all these kinds of constraints. And they also support in-flight optimizations that I haven't implemented, so I'm purely doing the front planning side. So what they recently released that's in beta, I got access to it. Anyone on the dev team can get access, is this web API. So you send your request to their web API, they have a server running, it computes your path plan, and then you can execute that on the drone. So this web API is very nicely documented in a tool called Swagger, so you can see example queries, you can try the API out on the web, and then you can use it to code generate if you want to use that in like another framework that you're already doing Swagger stuff. Their planner supports 2 kinematic models, one for plane, one for copter. We want the vehicle constraints to come from the autopilot. I haven't implemented that yet. It does support keep-outs with an operational area, and then when you query the planner, you can tell it what to optimize for. Currently, they support energy-optimized plans, time-optimized plans, so if you want to execute the mission really fast, or distance-optimized plan, which is typically what most planners are doing these days. It returns the paths as well as the predicted energy usage, so you know if you'll have battery to actually do the mission, which is really nice. They're planning, like I mentioned, it's using AI to help find those routes. It's under very active development. They're a startup and they're super adaptable, so they've already made some changes to the API to support Ardupilot. And this API makes it really easy to integrate with your own custom GCS if you're not using what I've developed. So to start, the easiest path forward for me to get this working with Ardupilot was with MAVProxy. I wrote a module that authenticates with their server based on a bearer token. You can configure the start and the goal and the vehicle constraints. We can send fences, and then you get back a path. And then we convert that for waypoints for an auto mission. There's the pull request. And if you want to try this out, you just need an API key, which I can help you get one. So using the plugin, here's an example with a plane where we fly across a larger area where you actually want to take advantage of these energy optimizations. So as a paragliding pilot myself, I know that it's pretty advantageous during the day to fly along the tops of mountains because that's where the thermals are. So you can see here, this green path is the energy optimized route. They're taking advantage of both the local wind gradients as well as predicted thermals. And if you took this path, you'd expect to consume less battery and end up having more battery for other maneuvers at the end. So to test this, I like to use CITL. I've also refreshed MAVCesium this last year, so anyone can use MAVCesium. You just use module load cesium in MAVProxy, and you now have a 3D view with a HUD, which is handy if you're flying really far away, or just testing in CITL with terrain. So that's now working with the planner, and you can see us executing a route right there. So for the demo, I just did something simple where I tried to create a plan to avoid the tree. You can see here with the geofence setup, there's the energy optimized route and the distance optimized route go different ways, and that's because of the wind coming from the south. It's more advantageous to go one way than the other. I did have to play around because this is quite a small area. Obviously, with a small area, the energy optimization is going to not really be that different, but it's just an example on a smaller scale. So some of the limitations right now are the fences aren't synced between MAVProxy and the planner, so I'm just manually hard coding those just for the purpose of this demo, so that's just something to implement. It does require your GCS or your drone to have an internet to call their planning service, but they do support self-hosting that planner if you want to do that. And the vehicle parameters are obviously also not automatically pulled from the autopilot, so we don't know like climb rate constraints or turn radius constraints quite yet. So as far as the demo earlier, what you saw was the quadcopter taking off to go execute a plan that I generated around the tree. And so what happened was, so I uploaded the path to the copter, turned on auto. Along the way there, it lost telemetry. We thought it was a GCS failsafe. We disabled that. We tried again. And then basically when it happened again, same thing. We lost telemetry. Ardupilot was continuing the mission. It tried to send a fence speech message, but I didn't get that because I didn't have a link. The vehicle turned around, ended up in RTL, And the reason for this was basically an inclusion, or a keep-in fence around the home location that I didn't know I had set up on the copter from a while ago. So that wasn't displayed. And then Ardupilot basically recognized this condition, came back home safely, but we couldn't follow the plan because it was outside the fence. So Ardupilot did what it was supposed to do and just missed something in some configuration. And then here's just the parameters I had for the demo. So if I would have looked at the parameters, I would have seen that. But this is the nature of doing a demo for the first time. I wanted to keep it exciting, and unfortunately didn't get to fly the route, but I at least know the waypoints weren't way up in the sky or below the earth, so it looked like it was doing the right thing with regards to terrain, flying nice and low. So I'm at 9 minutes. I think I'll skip the demo for now on Siddle, and I'll let Rhys talk about some of his work, and then if we have time, we'll come back to that.
You've got slides for that, Ryan?
Yep.
Okay. Some background on the demonstration we tried to run earlier and didn't quite manage. So a lot of our work is based off a planner that has been put together by JLIM and various teams at ETHZ. And this is for like dealing with path planning in very steep terrain. And they've written a really nice ROS package for that. We help port it to ROS 2, so that's all available online. But when using this, they currently use tools like RViz as a ground control station, and it's not very easy to integrate with Ardupilot and our terrain data that we have on integrated with our autopilots and tools like MAVProxy. So what it's very powerful. It uses the underlying paths that use Dubbins curves, so it assumes that there's a safe place to start, you can find a loiter to start, and you can find a loiter to end, and then given those two constraints, it will see if it can find a feasible path honouring various climb rate limitations for the plane, but also making sure that it stays within altitude bounds and satisfies kind of the terrain constraints. The public version doesn't include fences. I believe that there's a sort of like private repositories which do, but we don't have access. So that was the inspiration for our work. It's a very nice piece of work. It's documented. There's papers and details there. So we wanted to try and simplify that and see whether we could get something working, integrated with Ardupilot for experimenting on, and reduce the overhead of integrating. So we've ported the core planner to Python. So that's very slow, but it actually sits over the top of a very fast library, which is the OMPL library. This is a motion planning library for state space planning. It's used in industrial robotics, so if any of you are familiar with the ROS MoveIt packages, OMPL is the underlying planning library that's used to plan kinematic paths for robotic arms, so they avoid collisions and they get to start and end points. So it can be used with different state spaces, and the one that we're using it is this Dubbins airplane state space. The library here, Terrain NavPy, is the Python port of the ETHZ path planner. So the entire state space is written in Python, which means it's quite expensive and slow to calculate. But more recently, some of those state spaces have been implemented in C++. So there's a much faster version that we can run of this, but it's not currently integrated with our work. So it's a slow planner, but what's good about it, because it's Python, it's really easy to integrate additional constraints. So it was quite straightforward just to pull the fence inclusion and exclusion fences from MAVProxy and update the validator for the states to make sure that we could include that as well as terrain. And that makes it easy to deploy. It means it's easier to get across different platforms and things as well. So dependencies, MAVProxy's Python. You can write tests around it. So I've got a full test suite for the terrain planner in Python. And OMPL supply the binaries for a reasonable number of targets and against about 3 different versions of Python. So it's much easier to share and get this thing running on a variety of machines. So, as mentioned earlier, the planner obeys curvature constraints, so you can set a loiter radius effectively or a turn radius for the aircraft, climb rates, and the overall idea is that we're going to, it's a MAVProxy module for integrating the planner into MAVProxy. It's got 2 modes. It can either run as part of the ground control station, or it can run in a headless mode on the onboard computer. The planner itself runs in a separate process so that it doesn't stop the MAVProxy loop while it's looking for a solution and doesn't kind of compete with resources on the same thread. So it's a core library that can be integrated with other systems as well, so not specifically MAVProxy, so there's an API for that. So here's an example where we do have terrain, and so the general structure of these things is it's straight lines with curves, and there's a constant climb rate along either the curves or the straight lines. If you can't hit a state going from one point to another, the model will spiral upwards. So you've got kind of curves, or you're spiraling, or you're going in straight lines. And that's, so any path you'll see created by a Dublin-style planner will have that structure. It's a random sampling planner, and the way that OMPL works, it tries a different state sampler each time. So you're not going to, if you rerun the planner, you'll get a different route, and that can be useful if it can't find a solution the first time. I think one of the things about figuring out how to initialize it well so that if you want to force reproducible results would be useful. It does have the facility in it, but we don't have that shown at the moment. So then I'm going to just switch computers over now, and hopefully this comes up. Do we have, is it showing up on the screen? Yeah, okay, great. So it may have been a little bit hard to follow what we were trying to do this morning with the plane, because we don't have obvious terrain to fly around. We had to create some obstacles for the planner to work with. So here we've gone to town on putting lots and lots of extra obstacles in the way of getting from our start goal to our end goal. So the planner allows you to set a start, and then it sets a goal. And if you try and set the goal somewhere it shouldn't be, the planner's not going to like it. So the goal has to be valid for the planner to accept it, in that it has to satisfy both fence requirements and terrain. So the terrain here is pretty easy because it's all flat, but quite often with tricky terrain, finding a flat spot to loiter in will be difficult. Now, what we haven't done in the library so far, which is the hard problem, is when the plane fail-safes, it needs to find a safe place to loiter, and we would like to be able to do that on board. So the first thing that happens is the plane fail-safes, it goes into a planned return to land, and it needs to find a place to circle while it computes the return path. Now, that has to look ahead in some sense, and it's currently an unsolved problem for us. And ideally, it would be done on board rather than on a companion computer. So it parks the plane up somewhere that it can cycle around while a good solution is hunted for. Now, with the C++ versions of the planner, that should be computed within a loiter cycle. Because we're running on Python, it is not going to do that. So then, on the ground control station, we can use this for planning as well. So it's not just for, so if we say, can you find us a mission that will route around all these obstacles? So here the planner is going to start looking, and it comes up because it's a sample-based planner. It'll come up with a valid solution, which it'll lock in, and then it'll start looking for a better one. So you give the planner a time budget, and you say, I'm going to say allocate maybe 20 seconds to find a solution. So here we've got a solution that wiggles around all the different exclusion circles and gets us from our start to finish. Now, the next thing, the ETH planner is designed to be used with an off-board controller, so a path guidance controller. We have a PR for one of those, which is I haven't finished to do all the tests for. But in that case, the companion computer has the path and it knows the accelerations and the velocities that it needs to drive around, and it runs for that. So what we've done instead is get the planner to generate the waypoints. Here it's just done as a series of breadcrumbs. Another way of generating them is to link these with loiters and straight lines, and it's a much more natural path for the plane to follow, but there's some glitches in how it may cycle round and take you into an exclusion fence if we do that. So we then accept the mission and we set the plane off following the path. And off it goes. Now this is running, so the setup here, this is running Simon hardware. So this is exactly the same setup, apart from versions of the flight controller, that would be running in the plane. So the Simon hardware support in Ardupilot is really nice. It means you can flash your flight controller, but it'll have the CITL running on it, and then it's integrated with the Pi, so all the connectivity is all the same. And the idea this morning was just to have this working, which it was, and then basically drop the Pi into the plane and just switch the plugs over. But unfortunately, the board has had a kind of a change of pinouts on the way through, and we managed to choose the one UART, which had been moved out of all the other free ones, which is a bit unfortunate. So as we move, I'm going to wait for, because it's Simon hardware, I don't think the speed up worked. Are we out of time?
Pretty much, yeah.
Yeah, okay. Okay.
Questions? Okay, thank you very much both. A round of applause. Okay, we're now into the afternoon break, so we've got 15 minutes if you want to get yourself a coffee and something sugary. Ladies and gentlemen, please take your seats. Please take your seats. We're about to see Stephen's demo. Final call, please take your seats. Please take your seats. Okay, we are on to the final demonstration of the conference. This is Stephen Dade with ArduRover and Ross 2 Autonomy demo. Over to you, Stephen.
Cool, thank you. This was originally going to be an outdoor demo, but given the weather, I've moved it inside. Turns out my rover doesn't need GPS, so I'm fine to run in here. So I've been getting into ROS for the last couple of months whilst building up my rover here. This rover is derived from the Dade design, so you'll see some similarities to Tridge/Rhys's rover that they've been using earlier. So what I've done with this rover is it's got a bunch of stuff going on in it, so I'll just explain what's going on in the rover first, then I'll do the demo. So what I've got going here is I've got Ardupilot running inside the rover. I've also got a Raspberry Pi 4 running ROS to Jazzy. And the way I've done it is I've got a LiDAR on top of the rover, 2D LiDAR, and that feeds into the Raspberry Pi. And ROS on the Raspberry Pi will, as the rover moves around, ROS will automatically generate a map of the area using data from Ardupilot. So Ardupilot, in this case, Ardupilot's providing the IMU and the odometry data into ROS. ROS will then fuse that with the LiDAR scans and hopefully create a fairly accurate map of this room as I run it around. And I'll also show a small GUI I've been working on as well, a prototype ground station that you can use under ROS. What else have I got in here? In terms of the connection between the flight controller and the Raspberry Pi, I'm running a PPP link, and I'm running both DDS, that's what ROS 2 uses for communications, plus a MAVLink connection in there as well. So, and I've also got a live video feed from the front of the rover as well, running over all this. All of this communication's been done via the Wi-Fi at the network here, within a zero-tier VPN. So, what I've got going here is my little ROS GUI. This GUI here, that's all from ROS data. There's no MAVLink there. That's straight from the micro ROS gateway running on the Raspberry Pi. At the moment, there's not too much data exposed under the ROS topics. Hopefully I'll change that and add a few more in the next couple of months. We can get things like GPS data, longitude, latitude, which isn't showing here because I haven't got a GPS signal. I can get basic battery data, voltage, current, percentage voltage remaining, arm disarm status, flight modes, fail-safes, if any, as well as in terms of controls, I can arm and disarm the vehicle from here, as well as set some of the basic flight modes. As a stretch goal for this demo, I was hoping to be able to have Roz control the robot as well and do some fancy path planning. Unfortunately, I didn't get quite as far as that for this demo. So this is just going to be under control by my RC controller here. And it'll be Ardupilot feeding the data into Roz and Roz creating the map of this room. So if I get RViz up and running, so here's what the laser rangefinder currently sees. So I'll just expand that out a little bit. There we go. So what I've done here is I've artificially limited the rangefinder to about 6 meters distance, just so it's easier to see it as it visualize it as it goes running around here and adds to the map. So I've got within the ROS framework, I've got the cartographer ROS node doing all the mapping here and fusing the data. Then I've got the nav2 stack running, ROS node running as well. So in terms of this, what cartographer does is that will generate the map for us, and then the nav2 ROS node will do all of the calculate the paths and the object avoidance and so forth for path planning for the robot. So in this case, nav2 is running, but it's not actually doing anything because I'm just running manually. So what I will do is I will run this through and I'll see how well I can operate this from up here using FPV. All right, so I will arm it. Come on, are you gonna arm? And of course it refuses to arm now. Let's have a look. Why is it? Let's try again. There we go. I just had to hold the receiver differently, or transmitter. All right, let's go. And we'll see how laggy the video is. So we've reached the end of there. And you can see the map sort of, I'm going to have to zoom out that map actually. Hold on. Whoop. Okay, the map's jumped a little bit. Yes, sometimes the map will jump a little bit if the rover's been running for a little while. So let's turn that up a bit. All right, let's see if I can. So you can see as it moves along at the top there, it's gradually expanding out the map. You can see the red dots there are sort of the live feed from the LiDAR. Am I past the last table? Keep going? All right. Whoop. There we go. Yeah, there's a bit of lag with the video. There we go. I'll just run along the back there. And I'm trying to avoid knocking into anyone's chair. And that's the end. All right, I'll just move that map again. So you can see it's got the back of the room there now. It's come along the back and it's mapped all the back. And now I'll come down this side and complete the loop. Then I'll go up the middle as well, and we should have a fairly decent map of this room from the LiDAR. All right, so I need to turn around. All right, around we go. Ah, there you are. There we go. And it's reasonably accurate now that it's come back around. There's not been too much slip. Now I will come up the middle. Come on, round we go. There's the middle. Up it comes. Oh, I think that was my backpack too. All right, let's try that again. There we go. I'll come back down the other side. And thank you for not sort of trying to hit the rover as it comes by. All right, let's come back. Nearly there. Come on, there you are. So bring him back round again. All right, there you go. All right, let's have a look at that map. Oh, that doesn't look too good. Yeah, so one of the fixes I need to tune up at the moment. Yeah, as the rover goes around, you'll start seeing some offsets with where it thinks it is, and the map, as a result, will start getting offsets in the map if it hasn't revisited the area in a while. I do need to take a look at the cartographer settings. Go.
I do notice some latency in when it's turning. The points that it's seeing shift, like they get rotated. Is that possibly?
Quite possibly. I've been struggling with getting the frame coordinate conversions between Ardupilot and Rhys correct. The yaw may be reversed. That may be wise. Or it may be something going on there. That
It would be impressive if it still worked with the ArduRover.
Yes, very true. Yeah, Rhys, doing frame conversions between Ardupilot and Rhys has been a bit of a trial by fire. I still haven't completely got it. There's some patches I want to make it easier for other people. So basically we had all of this was running locally on the poor little Raspberry Pi 4. That includes the map generation, the video that was all compressed and transmitted via the Pi as well. Had some MAVLink telemetry in the background. Had the ROS2 DDS bus as well. In future, I'll add the navigation 2 as well. So the Raspberry Pi is doing a fair amount of stuff, and even though it's only a Raspberry Pi 4, it's keeping up pretty well with all of this. And I think that's about all I have to show you today. I'm not sure if we've got time for any questions. Yeah, if anyone's got any questions. Yep, Ryan's got one.
So I had difficulty tuning cartographer and Citadel. How much worse was it on the real hardware? Did it work out of the box?
It did not work out of the box. It definitely did not. Cartographer I'm finding very, very fiddly to tune. I need to record some ROS bags to have some data to play back. Because half the time it's been a case of the only way it would be tune cartographer, run the robot through my house, tune it a little bit more. I am finding I think there's some lag or time difference between the LiDAR readings and the IMU readings, which I need to investigate. I did have a nightmare of a time getting the time sync correct between the different ROS nodes. So I found ROS needs to have very tight timings between all the data feeds coming in. And there were some little lags in the system that I needed to fix up, or in some cases just fake some timestamps to just get things running along. So that was interesting. But yes, tuning is hard. I kind of got it working here. I find it's fine in the short term, but once you've got cartographer running for maybe more than a few minutes, you start to get jumps in the position. So I'd be curious to see if that's a problem with jumps in Ardupilot's position, or if it's cartographer trying to do something weird after it's got the fuse data. Or it could just be because I'm not running a GPS here, so Ardupilot's having a bit more of a difficult time with its position estimates. Yeah.
Thank you.
Are you running odometry on the wheels, or is it just...
Oh yes, I forgot to mention that. I'm running wheel encoders on the wheels. That's feeding into Ardupilot, so that's where my velocity calculations are coming into Ardupilot. And probably the only reason this does in fact run indoors is because I'm getting very good velocity estimations from the wheel encoders. So the GPS, I only need that for my positioning source in the EKF.
You might see a little bit of slip on the wheel odometry because it's a skid steer as it goes round, and that can sometimes throw the corners off.
Yeah,
as well.
You're right. Yeah, that could be an issue. Yes.
Yeah.
Wonderful. Thank you very much, Stephen. Round of applause, everybody. Okay, we'll just be a few minutes whilst we change over to Tom Pittenger, who's going to tell us all about what Kraus Hamdani have been doing with Ardupilot.
That's it.
Okay, next up, Tom Pittenger with his talk about Kraus Hamdani Aerospace and the enhancements that they've done in Ardupilot. Over to you, Tom.
Thank you. Hello, so I'm Tom Pittenger. Work at Kraus Hamdani Aerospace. We got a few people here at the conference: John Challenger, Stefan Kraus, and Sam Tabor. The talk I wanted to talk about was a bit more about Ardupilot as a success story and things we've done and contributed as individuals, as a company, and just like how a company would interact with Ardupilot. What it's empowered us to do is we make this aircraft that's a glider, a powered glider that is also a VTOL as an option to do like radio relay and high altitude, long range things. And it's really given us the ability to push the technology in ways that make us really competitive in the industry. We have the longest endurance for a Group 2 drone, which is the K1000 ULE, which is ultra long endurance. And obviously cube powered. Here's an example of soaring. So soaring's a big thing that we kind of did on the Ardupilot. We've done 12 hours just doing soaring with no motor, essentially flying around. So it's the capabilities out there for doing some pretty amazing things. We have a record for the longest electric aircraft for a Group 2 aircraft, and 76 hours, and a lot of that's limited by airspace, so just the time of the flight. But once you start repeating, then you can kind of fly forever. But yeah, so this is our longest flight so far, but we could easily extend that. The key thing here is how Ardupilot has enabled us to be successful in the industry. So we have our records, soaring, which gives batteries battery optional sort of thing, so we'll extend. Because of a flight like we had, motor failures sort of become a fun thing to play with rather than a catastrophe. And we've had propulsion failures so far away that we were able to sail back and soar up a little bit. But we've had motor failures way out in the past, so it's amazing. We've kind of pushed a lot of networking stuff because we're kind of a radio relay in the sky with all the IP networks and whatnot. So having IP backbone on the aircraft, that's adding IP native technology into the autopilot gives us better connectivity and whatnot. Flexibility on landing, that's been really nice, where we can land on a very small runway. Has anyone ever landed on a postage stamp size runway? Anyways, in-flight reverse thrust. Our aircraft glides so well that we actually have a problem coming down sometimes. So a long time ago, I added a reverse thrust for some other things, and now it's like, it's not for landing, it's also for flying. So sometimes you got to do reverse thrust just to come down. So it's interesting that different aircraft can be configured for different kind of capabilities. So it's amazing how flexible Ardupilot is in that regard. We've had on a regular basis, we're flying very, very long range for all this radio relay type thing. So we do beyond visual line of sight. That's just part of our business model for our customers. So very, very long range. We've been engaged with a lot of different vendors and manufacturers to bring more of Ardupilot technologies and associate, DroneCan and MAVLink to just bring the community, the ecosystem better. So it gives us a better compatibility with gimbals or whatever, the sensors. But it just kind of empowers the whole industry, the UAS industry. So, and giving back to part of that into Ardupilot, that's kind of even though it's our competitors, a lot of hardware vendors are always worried about, if I contribute back, then someone else will undercut us doing the same thing. But if everyone kind of does it together, it's one big ecosystem. It's really great. We have tons of contributions from our employees. Several people that contribute. And Stefan Kraus has been kind of financing a lot of this. He's been a big proponent for open source in general. So it's been real great that he's been able to kind of support us on all this. And also, we have perfected VTOL ship landing. And we've also the first one to do it. So, big claim, big claim. So, sometimes when you're doing your simulations and you mess up your models, it kind of becomes a yeah. I'll skip ahead a little bit but yeah, it's we did it. Yeah, and there's some serious yaw authority on these things too. So you spin those and right there, spin that puppy around. So we did it for the first. Yeah. 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 Yeah, we are looking for partners. If anyone wants to expand on that, so just. Yeah, speaking of partners, we've been working a lot with QPilot. We've been in their booth at AUVSI and just worked closely with them over the years. helping to bring things like the cube red, via network stuff. We're really kind of pushing that, so helping them test that and make it right for the high-end user. And then like what's next for us, and how does Ardupilot kind of benefit? How we get it back, and we're looking at the longest record for a flight in general. Just the longest flight is 64 or something days. So we're looking at trying to do like a 65-day flight, and that's it's fun to just kind of burn circles in the air. But maybe we'll do a fly around the world type of thing to do it. So it's kind of big things. So we've simulated some of these things, and it's just nice that it's kind of proving out that Ardupilot is capable of such a thing, right? So it's kind of amazing that this thing is just so capable. So contributions that we've kind of added to Ardupilot, lots of fixed wing stuff. I can go through these, but it's kind of listed there. But lots of networking things, and improvement to solar panels in general. Aircraft are solar powered, solar electric. Well, a lot of these are kind of like not your normal hobbyist sort of cheap drone features, like for example ADSB. That's nice. A lot of people think of ADSB as an in, but when you actually go into larger controlled airspace, it's all about not just ADSB out, but like the big boy transponders that are actually on the aircraft. So dealing with things like that and being in a coordinated air traffic control sort of situation and seeing how Ardupilot can interact with that is a good trend. I'm going to note here, improved WSL2 support. I've worked on that a little bit, but big thanks to Sid. I've been working on it a little bit, but he gets all the credit there for WSL, for his Visual Studio plugin. Like definitely, if you guys aren't doing that, that's great. You get debugging support and everything on it now, so plug in him on that. So lots of stuff that we, as time allows, we want to kind of push back into Ardupilot. We've been going like crazy, adding features and bringing up capabilities. So these are kind of things on the horizon that I'll be making pull requests, or we will be making pull requests to kind of push back. So lots of fixed wing, just improvements in general, and motor testing. We made a new flight surface called Breakervator. So it's kind of a weird one, but having your elevators act as brakes just induce drag a little bit. Having manned your CAN talk to multiple ports, and things that you need when you start kind of bringing your vehicle up to a scale where you have to have customers that don't know anything about your aircraft, that they have to start using it, and you make tools that can kind of configure your aircraft, param management, and we have tons of peripherals on it. I think we have like 5 peripherals that are on board now, with many more in the works. But AP Perif, I've been doing, I keep saying me, but we're doing lots of work on AP Perif, adding capabilities to that. The library set that's in Ardupilot is just so extensive. That's one of the most valuable things in it is just all the drivers that are in there. So being able to take advantage of it through AP Perif and having payload managers, or I have like we made a pitot heater. So it's not a problem that most people come in contact with, but you don't want to just turn your heater on and just have it on all the time. That's the normal thing to have. Have a nice thermostat sort of system. It's like a little mini computer, but it's just a periph, right? Networking, improved network support, doing more things with networking, making it easier for connectivity, and relays, so you can say toggle GPIO and have a duration to it. Take the load off of of your GCS systems. And more about manufacturability, where we get PCBs and whatnot. We make almost everything in-house for that stuff. And we have to test them all and put them through the paces before they even touch an aircraft, let alone test fly that. So I've added a lot of things to Autopilot and Perif to do things like serial loopback and all these and stuff like that. That's in the Autopilot that you can kind of put it in test mode, and it'll test itself and kind of pop out messages, say, everything's all good, and check the IMUs and whatnot, and kind of just do a big course. Yeah. So lots of stuff. There's actually, it just goes on and on. We actually have a lot, it didn't fit on this page, so I kind of squeezed it all in there. But yeah, we've been kind of focused on making features and less pushing back, so I want to make sure I kind of allocate some time and start getting all this stuff in there. Also want to talk about how a company, how they interface with Ardupilot, and the problems and things that we could, that as a community that we should kind of think about how we can improve that experience for some other vendor, whether a partner or not, but just anyone who uses Ardupilot and we want to interact with it, what we can do. So this is a very controversial thing, but merge versus rebase. I know everyone loves rebase, and some people love merge, and so there's that. But the major downside is your hashes disappear when you rebase. So if you have logs and you've done a flight test and then you did something and we're like, oh, we need to change that, and it's a pull request or whatever, then you rebase it, all those logs, you kind of lost your hash unless you just start keeping tons of branches, and that becomes annoying. So there's huge benefits to merges. So that's handy as far as paper trail to know what you've done. Because a lot of times when your aircraft gets big and expensive and the logistics become huge for that, every single flight becomes valuable, and that you need to reference back to it or something in time. I might want to look back 5 years and say, this flight was done on this code, how did it perform or whatever. Misinformation is big, where I still, this was mentioned on an earlier slide, but people think we run 8-bit Arduino, and that's us. And so it's just, it's because our name, right? Arduino, Ardupilot. So that's just something that it's hard to, our Ardupilot's marketing department could use piles of cash to help our outreach on that regard. Same thing with and this is just, so some of these problems I shouldn't say are specific to Ardupilot, but just projects in general too, right? But open source means low quality. That's what all the closed source folks like to advertise. So it's kind of an ongoing battle in general. Learning curve for Ardupilot. It's one of those things where the best thing about Ardupilot is it's got like 2,000 parameters, and the worst thing about Ardupilot is it's got 2,000 parameters. So people don't know what they don't know about it. So the learning curve is steep, and usually a lot steeper than they think, but there's so much documentation out there and just manuals and experience from people and YouTube videos that people kind of get enough to get by, but really people usually just have the minimum and they fly on fly-by-wire and that's it, and I think that's what Ardupilot's for. And no one would dare use auto or even auto land. Like it drives me nuts that people don't do auto land. I'm like, just try it. People don't even try it, right? So yeah, it's get companies or whatnot and users. We should do a better effort somehow to kind of get everyone up to speed and make that kind of easier for them somehow. And when I say here, what does Ardupilot even do? It's one of those. It would be impossible for us to make a list of like this is what we can do. Doesn't matter what we do on that. We're missing things, right? Like we ask stuff all the time, but just like there's no way to itemize our features. It's just they're so long, it's so extensive. People ask, right? They say this autopilot. What? It's like, well, here's these 10,000 things it does, right? So it's just it's hard to. Again, it's one of those our image/marketing, whatever we'll call it, but it's outreach of some sort. And that's from a company when they say this autopilot was this autopilot, this is one. Why is yours better? What can yours do that this one doesn't? And it's like, well, you kind of like dance around saying we can do this and this, but if there was some sort of bullet points or something, I don't know. There's no real answers to all these. This is just kind of like problems in general that would be nice that we could improve. Consulting, I say consulting here, but really kind of what I mean is like more experts that are available for work. Like a lot of times companies want to use it, but then they may not want to use it just because they have they know that they'll have some problem, and it's like, well, we just want to pay $20,000 to make this problem go away. And it's like, that's not as easy to do in Ardupilot versus some other projects. We kind of need, or I should say in open source in general. It'd be nice if we just get more people involved, more developers, and get their experience up so they're more competent to just get more people into it, you know. The upstreaming PR process is a bit daunting, and from a company's perspective, it sometimes becomes hard to, I shouldn't say hard to, but it becomes a cost risk analysis, essentially, of like they put effort into it, and it's like, oh, you want more effort? Oh, you want more effort? You want more effort? So that at some point they're just like, why am I bothering, right? So it's good as a project that we should make sure that we not just try to make that as easy as possible, but somehow figure out a way to just encourage that, because when we don't, it becomes on the core developers that have to deal with all that, right? So it's in our best interest to try to get try to make the whole experience better somehow. I don't have any good answers for that, but it's definitely a barrier of entry for other companies that are paying employees to get their PR in. Because we'll almost always say, okay, that's nice, but can you change this one thing? And oh, by the way, does it work on master? They don't fly on master, right? Companies are always on the latest release, and then it's like, oh, well, if it's going to merge, it has to go on master. So, well, are you expecting them to suddenly put their code on master to go fly it? So you have these barriers that a lot of us don't realize, that you can't do that when you have a plane that's worth $1 million or whatever. So, and each flight is very risky. Like, you have to just treat the whole situation a little differently. So again, there's no good answer for it, but that's just a kind of a barrier of entry for bigger companies to try and making these products to get into. And then managing a fork. So when you have your own fork, you're usually based on some release, and then you are, the assumption is we started here, and sure, someday it'd be nice to go to the next version, but there's so much work to get there. We should really work on trying to make that an easier experience, and merge versus rebase is kind of one tool that could be used for that. But one of our best and worst things is our upstream. The main master branch just hauls ass, right? It's always like thousands and thousands. You're going to the next release, you're like what 10,000 commits behind or something. So it's like the concept of rebasing or whatnot is daunting. But we want to make sure we try to get that working, improve that experience somehow, because all these companies make code, and they usually are very, very important and very useful improvements. And so to them, it's just, if it's zero effort, sure, we don't care, but if there's any effort, not worth it. And so if anyone sees more than zero effort, or more than trivial effort, then it just becomes, I'm not going to bother. So, just kind of work on that. And private repo in general, I've actually made a few commits to kind of improve this experience in general, but to some companies, it's just a necessary evil. They just won't or can't or something, so they have Ardupilot in their own little repo. And that's not necessarily the big problem, but when you do that, suddenly you're with GitHub CI, and our CI on open source is totally unlimited use. It's free. But on a company, you start burning thousands of dollars on that. Tim, you have a question? Oh, your mic's not on. The longest question ever.
Yes, and just to start again, not so much a question, but that's a great list of comments on some of the challenges with working with Ardupilot. And to me, there seems to be mostly a common theme there, and it's a thing that I've seen too. Configuration management, fundamentally. And there's a couple of others that I'd throw in there as well, related to it. One is managing what firmware you've got on a board. For example, sure, you can tell which hash it is, but which custom firmware build options were in that particular firmware that is on this particular board. Another one that relates to it is managing, when you're on a particular vehicle, Lua scripts. When you're dealing with Lua scripts, which versions of which Lua scripts that go with which firmware that's on the board. There's I mean, software configuration management, and we use GitHub, is, you know, been around for donkey's years, et cetera. But it's, you know, I keep struggling with an idea that I want to be able to have, like, here's a standard configuration for my vehicle, click a button, make sure the right firmware with the right build options, with the right Lua scripts, with the right sets of parameters, because actually parameters should be able to be configuration managed as well with check-ins and check-outs, instead of the download and upload thing that we do right now, which is all manual with all of the errors and emissions and things that can happen with that. And just sort of generally speaking, I'm sort of agreeing with you in the sense that I think that that's a thing that we all need to think about. This needs to be able to be managed, and it's going to get even more important than just, hey, that's a niggly thing. You know, we're seeing, for example, in our new regulations coming in Canada, that there's a requirement to be able to say, demonstrate and document what are your software configuration management, hardware and software configuration management processes around how you're actually managing your vehicles. So, yeah, a really, really, really important comment that you've made there around that. Thanks.
Yeah, so parameter management and hash management, I guess. Yeah, that too. Yeah, it's almost like we need a hash for the features or the configuration of it, and then a hash for just the commit you're on, right? Because when you compile, you can set all these defines and it doesn't change your hash. It gets trickier when you start doing things like or embedding Lua scripts, or even if on SD cards or whatnot. Yeah, because it's hard to tell what version of Lua you had when you flew, because then that changes your behavior, and you can blame the C code or whatever, but it's like, well, really Lua was doing some crazy thing, and it's like, well, can't tell by the log. So, yeah.
Your Lua scripts, your parameters. Your Lua scripts and parameters will be locked down in your build. You'll compile them in for sure. So it's really a development problem that Tim's talking about there.
What was the problem? The manufacturability thing you said?
Yeah, I know. I could hear myself, but apparently no one else could hear me. I was just saying what Tim was saying before. That those things should be baked in when you're releasing your production firmware, in that you're baking in your Lua scripts into ROMFS, you're baking your parameter defaults into your hardware dev. So all of those things for a production vehicle are managed with the firmware release. So it's really only a production problem that I think Tim was talking, sorry, a development management problem that I think Tim was getting to.
Like baking in your defaults and whatnot. Yeah, and those may or may not be known in your hash. So a good hash.
With the extension as well, to be able to set all that stuff and just bake it in the firmware.
So that's it. Yeah, we had our still ship there, but that's it. Anything else? Any other questions? Thank you.
Okay, bear with us just one moment whilst we reset, and then we'll bring the conference to a close. Just 2 minutes, please. Okay, if I could just have your attention, please. So thank you very much, everybody. It's been an absolutely fantastic 3 days. I'm over the moon. If you will bear with me just for a moment, I'm sure you appreciate how much work and effort and time and people that is required to pull something like this off. So we've got a lot of thanks to give. So first of all, an enormous thanks to all of our sponsors. So round of applause. Without their immense generosity and support, things like this just would not happen. So, yeah, absolutely, really appreciate it. And what a fantastic venue. The immense generosity that Ben has shown us all, and 3DXR. So, I have no words. So Ben, honestly, thank you so much. Throughout the conference, lots of people have been coming up to me and sort of saying, oh, wow, this is amazingly well organized, and all the attention to detail, and people have been super impressed. That's not a lot to do with me, if I'm honest. Becca has been our point of contact at 3DXR. She's the one that's been doing all of the organizing from 3DXR's point of view. And honestly, this just would not happen without her. She works insanely hard. She's amazingly organized, and I'm just over the, just thank you so much. So Becca, we've got a few things for you, if you could come up on stage. And you've all interacted with just the team at 3DXR. To all of you, you're an amazing team. And I'd worked with some of you before, but I've never had a chance to work with you all properly until now. You work incredibly hard. Your attention to detail is fantastic. You're just so dedicated to your job. And Ben, you've got a fantastic team. Without you, this just would not happen. So please, just an enormous round of applause for everyone at 3DXR. So as a very small token of our appreciation, we've got a bunch of chocolates and things like that so that we can put in the workshop and in the shop. You're probably sick of sweet stuff, but we'll add some more to it. Okay. In the lead up to the conference, we're having to deal with a lot of people, we're having to deal with a lot of partners, and what many of you may or may not realize is that we've had a huge amount of help from Rishab. So Rishab, again, thank you very much for your help. Please for Rishab. As a bit of a change this year, we've had a lot of positive comments about the production value in terms of the live stream and just everything that we've been showing on screen. That's brought to us by our friends here at Q Branch. Your professionalism, absolutely phenomenal. The quality has been brilliant, and working with you has been great. So please, a round of applause for Q Branch. And then what's the point in a conference if you're not going to have people to come and do your talks and do your demos? You know, speaking from experience, it's incredibly stressful to do a talk or to do a demo. And the amount of work that goes into pulling that off is enormous. So a huge round of applause for everyone that's done a talk or a demonstration during the conference, please. And our final thanks, it just goes to the wider dev team and the whole Ardupilot community. The nice thing about the conference is you get to talk to quite a few of the old hands, and they tell you a little bit about, you know, how it was a very small community of only 1,000 people to start with, and it's just grown and grown and grown. And it's made up of people who are incredibly passionate about what we do, and without all of these people all working hard and all pulling together, that's basically what enables us to fly hundreds of thousands of vehicles around the world in all sorts of amazing applications. So one last round of applause to everybody within the Ardupilot community.
That's not the last round of applause, I think, Matt. So, final round of applause. I'd like really everyone to be upstanding for this. The effort that Matt and Pete and Michelle have put in over the last year has been just extraordinary. This has been an incredible conference, absolutely incredible. The contributions are enormous from 3DXR, from all the speakers, but especially the three principal organisers, Matt, Pete, Michelle. Thank you. Everyone. Take a bow. Fantastic. Thank you all.
Thank you, everybody. Thank you. And with that, we draw the conference to a close. Thank you very much.
Thank you for joining us for the Ardupilot Developers Conference 2025. With thanks to our sponsors, 3DXR, Aerosystems West, CUAV, CubePilot, High-Tech, Holybro, IR-Lock, KH Unmanned, Kraus Hamdani Aerospace, Maytech, Modal AI, Northwest Blue, SD Model, and Theseus. Organised by KH Unmanned. Hosted by 3DXR in North Yorkshire. Broadcast by Q Branch.